Hey, it's Tuesday, December 29th, 2020. I am your host of Brandon Show, Brandon Toy. Hope everybody's doing good out there. I'm doing pretty good. Been a busy day. I got a little presentation put together for you all about triangles and other stuff. It's not going to be as boring as it sounds, hopefully. I'm not going to be going over, any theorems or proofs or anything, but we are going to be applying it to a certain subject that has been discussed lately and very, very, very bandied about by the ballers. So that should be fun. Give me a thumbs up if you can hear me, and that would be appreciated. Sorry about that. Got distracted for a minute. Let's see who's out in the chat. Etsy Montreal, Tomcho56. Good morning to you too. Ian Adams, Strawman Dan. Let's see here. Helvetica Bold. What's going on? Channel member Helvetica Bold. Rito Notchcan. I hope that's closer. Fact Use. The Plain Truth. Enigma. What's up, guys? Hope everybody's doing good tonight. SE Montreal says you guys can't hear me. I have a feeling he is lying, but I think we're all good. I see a thumbs up. Ian Adam, thank you, Ian. Let's see what else is going on. So there's been quite a bit of discussion about the Mage 2, or not Mage 2, the garage, Pebble in the Pond's garage footage. A little bit of denial going on out there, but mostly I hear, oh, it's not a big deal. We knew about that for years. What's the big deal? What about these other pictures? So it's not as if the only thing we talk about are images with inferior mirage. We know there's multiple things that happen in the atmosphere. We know there's multiple phenomena that can block the bottom of objects. We've seen it. We've seen it with our own eyes in many observations, thanks to Ranty, Travis, and others. This is not news. We are not saying that the only thing that blocks objects from the bottom up is inferior mirage. But now that we have solidified that fact that the atmosphere via inferior mirage, mirroring, can block the bottom of objects, I don't want to see any pictures with mirroring put forward as proof of a globe Earth. Not one. So anytime you see somebody put a picture up and say, look at that Earth curve, and it's got any mirroring in it, you can just say, well, look at this footage. I'll show you what's going on. This is this phenomena. And that should be the end of the story. All right. Enough blabbing. We will do the presentation after I join the panel. Let's go ahead and say hello to everybody. Oh yeah, forgot to shill. Hold on. Let me just get the shilling out of the way, and then we'll be all good. If you wanted to support the show with a donation, which is very much appreciated, here's the link. It's to Streamlabs. If you have any problems, let me know. I know some people say it doesn't go through, or it won't let them, or whatever. But that's appreciated. Super chats, channel memberships like Helvetica Bold and others. And the best way that you can support the show is by coming in, showing us some of your observations, coming in and talking to us, giving us a new argument, pointing out something that we haven't noticed yet, or just, you know, hanging out in the chat, going back and forth with the ballers, chatting on videos. Anything you can do to get involved is awesome and appreciated. So thank you guys very much. Okay, let's go see how everybody is doing, and let's get this started here.
It was the environment somehow. You know, how would you ever figure that out?
Well, I'm pissed off because I like taking good shots, and like I say, you know, there should be a good reason why something doesn't work. I mean, it's clear as a bell out there, and I should be able to get some spectacular shots, and I get bullshit. And that's 12 miles away and at the moon, day and night. The shooting's bullshit now. I'll try again tonight and try some day shots tomorrow at the mountain, morning and evening, you know. But, well, we'll see what happens. But there's something that really is changing the light coming through, whatever. But I'll find out tonight more. But I don't think I'll get much better a shot if the moon is out and clear as a bell like yesterday. But I'll try. Report back tomorrow.
What's up, guys? How's it going? Jimbo, I heard you talking about doing some observations. Hello. That's awesome. We got Brian Leakey. What's up, Brian? Brian, who's got a new video out. And we will plug that tonight for sure. We got Helvetica Bold. How you doing, Mark? We've got Travis, Ether Band, who also has a new video out.
Hello, what?
What's up, man? We've got Jeremy. What's up, Jeremy?
Yo, what up?
Let's see who else we got. I got distracted for a minute. Sorry about that. Jimbo, Patient Zero, Aaron. What's up, Aaron? And the real Bob Dole.
Hello.
Hey. Hope everybody's doing okay tonight. Before I came on, I was just talking about the fallout from the garage footage in our visit to Gems. You may have seen it. Ranty threw together a little clip from that, and I thought that...
Yep.
Oh, go ahead.
Oh, yeah, I saw it. Left a comment. Really good.
Yeah. I thought
is it that about 2-minute one?
Yeah, it's real short. I thought we'd just play it and have a good laugh to start the show off.
Watch a gem melt. Okay.
Exactly. And he titled it Gem Panda's Utter Destruction and Cognitive Dissonance for All to See. Very good title. Howard,
how y'all doing?
My Discord link goes to the install page, not an invite. I will fix that, Howard. Let me just I'll put an invite in chat right now for anybody that wants to join. I'm not sure why it did that, but here is an invite.
Well,
there you go.
While you do that, man, I wanted to add before we get too far off the subject, is that cold air coming in from over top in the warehouse is also why they say we could see. I mean, you probably brought this up, but I just want to reiterate it, that they say that's why we see them long distance like Black Swan, and that's why in the Josh Nowicki photo we could see like the Chicago skyline, right? So that leads us. That means more is gonna have to be done. So Peter, you ain't done yet, buddy. We
Oh, refraction is not happening the way they claim it is. They need it to be happening the way they say it is for their globe model, but it might not be happening like that in reality.
Exactly. That weatherman specifically said the cold air. He's got the same graph Rumpus has. Speaking of Rumpus, yeah, man, I had to make a video on him, man. I mean, I know I ain't a big chair, not like that, but a shot's a shot is the way I see it. But the way, man, you gave, I don't hear you hand out, compliments just left and right, unless, and so far that I've ever seen, that they're well deserved. And you gave him a pretty humble compliment for him just to piss in your face, man, right afterwards yesterday. I didn't like that, so I made a screw off video for Rumpus showing how stupid he is and how he doesn't understand math. He can do math, but he doesn't understand math. It's easy to recognize. Go to my channel and watch the video I posted this morning and show how Rumpus has no clue about the mathematics going on in real life. I'm not talking about these formulas and equations. I'm talking about math used in the practical world. The whole server, I mean, everybody, the audience, the panel, even knows, everybody knows what's going on except Rumpus. For like 30 minutes, he's just dumbfounded. He's got no common sense. He doesn't know. He knows the rules of math, but he doesn't have the brain for it. And I exposed him on my channel, so watch that video.
Yeah, I watched it earlier, Brian. I really enjoyed it, man. And I especially liked what you said in there about, anybody can learn, almost anybody can learn how to do equations and trigonometry and all this stuff. But common sense and conceptual thinking is a different skill, and not everybody can learn that. I thought that was very good.
You can't teach that, man. Look, math is all rules. It's all rules, and there's no interpretations of shit. It's definite rules. So it might take you a week, it might take you a month, it might take you years. You might already know it. You may need to brush up on it. These a-holes are acting like they're superior to us because they use math all the time. And in a lot of cases, people that are the best at math, they sacrifice in other areas like, life, freaking, important things. And Rumpus falls in that category. He doesn't understand. He understands the numbers great. He knows the rules. He can memorize shit, but you get him off the beaten path and he's lost. That's why he says like air ain't atmosphere and freaking and math ain't, or measurements ain't math. He's a boy. He's a little child, man, with a good memory. And so I think I exposed him without going overboard. Thank you, Brandon.
Yeah, I thought you did too. I appreciated that. That was good stuff. And we're going to talk a little bit about triangles and mathematics today. And I'm going to apply those principles that they tell us we should apply to Polaris to another observation. But before we do that, let me play this video. You guys might not be able to hear it in the Discord, although I'm going to try something different right now, okay? I'm going to change my audio setting. That'll mean that I won't be able to talk to you, and I want to see if the audio will come through. So let me share my screen, and then we'll try that, because I'd much rather you guys heard everything that goes on when I play something. So I'm going to change this.
So I'm to understand you figured out triangles?
Yeah, well, it's really tough, man, especially when there's triangle calculators and all this other shit out there, tough stuff. But yeah, it's silly. Let me see. That's sad, Brian. That's the best argument that they came up with, and so many people have fallen for Katz's kind of Jedi mind trick that he pulled during that debate. They're
gonna pay for that, dude. They're gonna pay for that, because man, what took you minutes to learn might have took others an hour. They're geniuses, bro. They know them triangles, man. Yeah, they're gonna pay for that one over the next couple of weeks, I suspect.
Hell yeah. So let me play this video. I just figured out I can't share the audio, but let me put the link in the chat so you guys can at least watch it if you want. Or if you don't, I'll just put you guys on mute and then play this video for the audience so they can see Ranty's fine work. And I'll do that right now. I'll mute myself. Okay, so let me hit play on this thing here and I'll make it bigger for you. And I should probably unmute
But
it.
what we can
Let me start it over.
I mean, it's difficult really to see what's going on, but what we can conclude from this is that, you know, different layers of temperature, you know, create different refractive effects, which we knew. It isn't
Right, you asked
covering
the
it.
question, don't
It
be a
isn't
jackass.
covering the bottom.
We see the light disappear. Then I see the light flash back on again. Then I see it flash off again. Then I see it flash back on again. All of those times I see it, it's in the same position. It isn't moving down and being obstructed. It goes on and off. You see the light, you don't see the light. You see the light, you don't see the light. That is not the light moving up and down. That is the light being turned on and off, or who knows what's happening. So how does a clear atmosphere obstruct
I
something?
don't know, but
Go
you're
ahead.
watching it
You
right
just
now.
witnessed it.
How does that work?
You're watching it.
Demonstrated it for you, Jem.
Completely see-through atmosphere
Unbelievable, Jem.
obstruct
You're
something.
delusional.
Yeah, that's
Jem, he just
saying
demonstrated
that
it.
see-through things can obstruct something. That's fucking delusional.
You're watching it, Jem.
You just saw it, dude.
Jem-
With your
Jem.
own eyes, dude.
No, how
We
can
see
they
the
be
mirroring
obstructed
all
by
the time,
atmosphere?
Kosho. All the time.
How can they be obstructed by atmosphere? Where's that idea?
You're
from?
watching it, Jem. You're looking
No,
at it happen.
No, I'm not.
He's
I'm
calling
saying
mirroring.
something not very clear.
Well, now it's not clear enough to see it.
Look, it's all blurry and horrible. Of course
Are
it is.
you
It wasn't all the
kidding
way
me?
through.
So you
Yeah,
knew
when
that
this
the
happens,
atmosphere
reality.
can block something from the bottom up
Yeah.
already,
No,
Jem.
when this
That's what you're telling
No,
me. You already
the
knew that.
atmosphere can't. The atmosphere can't.
Well, then what's blocking the bottom of the boats and the light, Jem?
Nothing
That's
That
what
is
I'm
so
saying.
light.
stupid
When
what
this
you're
happens-
saying right
when this
now.
happens-
Nothing is
in reality.
blocking the
What
light at
caused-
any point. My question is, and this is why I think this idea is so absurd, because if this actually happened, if things did disappear from the bottom up, just as a consequence of distance, then we would be seeing this happening all of the time. And we don't see it happen ever. It's not part of our everyday experience, and people would understand that it was. They would have to account for it in certain circumstances.
Great job there, Ranty. Really good job putting that together. And that was pretty damn amazing. Let me take these guys off mute. So that was pretty damn amazing. We just got finished watching it. Really telling what he says there in that video. I mean, he's looking right at it and still saying, how can the atmosphere, just the atmosphere, block something from the bottom up? If that was happening, we would see that all the time. Now, my question to the panel here, particularly Travis, because he has the most experience, and the others that have taken a lot of firsthand observations, do we see that phenomenon out there in the real world?
All the time, and it's optical activity that cannot be avoided. And it's like day in, day out, every day of the year, you'll have something happening with your visuals of the horizon and, you know, distant objects, buildings, etc. It's not going to be the same every day, every hour, every minute, ever.
Yeah, I was really happy when I woke up this morning and saw that Ranty had done that, because I wanted to find that timestamp. And so I don't know if you watched my version, Brandon, but I put out a version with a quote from Andrew Thomas Young, where he states that it's been known since the 1700s or the 1800s that mirages block objects. You know, so you've got a mirage that's in the air. So when he asks the question, how can a clear atmosphere block something? Right? You have to understand the nature of a mirage and what happens, but that's, so you've got Andrew Thomas Young, the foremost authority on astronomy, optics. So shout out to Ranty for cutting that out and then letting me pirate it.
Well, it's really interesting, the different reasons that I've heard, or the different arguments back from the globe side. One of them is basically just, well, this is no big deal. We knew about this. We knew about this. Another one is, it's not being obstructed. It's being mirrored. As if to say, it's not the atmosphere that's blocking it. It's the mirroring that's blocking it, which I don't understand. It's just obfuscation. That's what it sounds like to me. I don't see a distinction.
Again, that just shows the fact that they don't know what they're talking about, because again, Andrew Thomas Young, the 2 videos that I put out today, I linked the title of the article so you can look it up. But in that article, he states that it is the medium that is doing the obstruction, whether it's a mirage or whatever you want to call it. It is the air. So, but you see, what the problem is that when Jem was saying it's turning on, it's turning off, it's turning on, it's turning off. When that light is gone, there's no mirage. That's what we're talking about. We're talking about the fact that that light has been swallowed up in itself by internal refraction. You know, so the fact that even with Ruhif in the general chat, he says, why are we talking about this? We've known this forever. Well, the long answer is because you don't understand the ramifications of what's happening. You might know that, oh yeah, sure, we've known that, but you don't understand the ramifications in the discussion. So
yeah,
that's
I concede to Travis. Every time I always listen to hear what Travis has to say, not because I don't have my own opinions and all that, but because he's got more time than most of us put together, and I like to hear Ranty's opinion. And I have an opinion, but man, yeah. So this is who you want to ask when you want to hear about atmospheric effects and stuff, man. People make fun of you talking about ether band, boy. To me, that's what better to call it than the ether? There you have it. Clear air blocking a light 100 yards away. Stick that in your pipe and smoke it, panda.
Yeah, Ruhif, it sounds like you were about to say something. I know you were just mentioned by Travis, so.
Oh no, just saying that I'm here. That's all.
Oh, okay. How's it going? Yeah, we've had a couple more people join. Dave Key Life joined, and let's see who else did. Fe Evangelist, what's up, Fe? Also joined us. What's up, guys?
Hey, buddy, how you going?
Has anybody heard any good arguments over the last day or recently about why this is not a big deal, why this doesn't matter, why it doesn't further our understanding of what's happening in the atmosphere?
You've got to keep up to date with the flat earth debate, Brandon. This was discussed on Nathan's years ago.
Then why are people still out there arguing against it and acting like this doesn't happen?
I don't know.
Yeah.
I'm happy to say if you think mirages cannot hide the bottom of objects, then you're wrong. Because inferior mirages do.
Fantastic.
Amongst other things. And here's the thing, every new phenomenon we find, we just got to wait on their explanation, because 9 out of 10, that explanation shoves them tighter into that box. You know, they done lost the horizon, and I can go on and on, but you understand.
Exactly. So this is one of the phenomena that can block objects in the distance. I don't think that this is a minor consideration, because we see this or something similar all the time. And it points to the underlying truth, which is the atmosphere itself. Just the atmosphere can hide objects that are directly in our line
now
of sight.
where globe trolls are coming on to agree with us and to tell us we're right in a condescending way. We've talked about it, and we always agreed that this mirroring.
Yeah.
We love that you agree with us, because it means you're learning something.
Oh, please. Give us the Mother
That sounded
Teresa
so condescending.
Yeah, well, there's still a bunch of them crying that nothing can disappear on a flat surface. It's just not possible. Erebus, Jose, and them, you know, shout out. I ain't trying to stir up shit. I like them guys. I join and get into it with them, but they're just flat out in denial and get upset, kicking people out of shows and going off on their own supporters, heliocentric supporters, just fighting with each other because no way can anything flat create a mirage, and also no way can anything disappear unless it. I've heard you, Ruhif, say that geometry won't allow it. I'll dig it up if you'd like, or you could concede now that you said that that's not the way geometry works. I can't quote you word for word, but I heard you on this channel speak of how geometry works and how if we have a line of sight to it, the only way it'll fade out is through angular resolution, disappearing equally.
Yeah, I'm sure context will be important to that conversation.
Okay. All right. Well, so that's that. Go check that video out if you want to. Travis is on there. I linked it in the chat, and Brian's is on his channel. I'll also link that in the chat. So, Ricky, I see you're posting some images in the chat. I don't know if you're able to talk right now, but you have examples where mirroring is not a factor. And we talked about this a little yesterday, so I'll just briefly bring this up. But yeah, in images like this, I don't see any mirroring here. This is not caused by a inferior mirage. We acknowledge that. We know that there's more phenomena. This one here. Oh, did it open? There's no visible mirroring there that we see, maybe up close, but that is not the deciding factor in this image. So there's definitely images out there that this mirroring, this inferior mirage, is not what's blocking our view or causing us not to see the object.
Don't need a mirroring or what they call an inferior mirage to have obstruction by the atmosphere. It's caused by many different things and combinations of thereof. So then you factor in the angle of the light source, the angle of the viewer, and the distances. So at 1 mile, one thing might be happening. At 5 miles, another. At 10 miles, another. Ruhif and all his pals can't explain all that all at once. They just stick to one and argue till the cows come home. And then once we prove it, they say, oh, yeah, we knew about that forever. I've been fighting this for 2 years. And I never heard Ruhif step up once. I might have missed the one time that he did, but finally convinced Zanuck and a couple others about 8 months ago to start admitting it. Jose semi-admits it, or does admit it, but then fights, when we talk about perspective.
How long have I been saying get above the surface to do your observations?
Yeah. We know all that
years,
too.
right? Yeah,
sure.
Right. Why have I been saying that?
Because the atmosphere.
Since the fish tank, Jim. I mean, Ruhif, since the fish tank. That's how long.
Since the fish tank? When was the fish tank? That was like this year, wasn't it?
Since Brandon's observations, that's when you started. That's when I heard it. I could be off, but
well, I'm sure I could point you to an old video of mine.
I'm not going to argue with that, though, Ruhif. I mean, I'll give you that if you want to go higher, but all the phenomenon are down here, and when you get up high, shit blurs out when it disappears. I mean, that's not even a fair argument.
When you get up high, you get above the highly variable atmosphere close to the surface. So your refraction is much more predictable. You can look at things a long, long way away, like mountains, and see that some enormous, stupid percentage of a mountain is hidden. I mean, there's even pictures of Canigou where if you analyze them and show that the angular size of the mountain and like overlay it onto the image, there's actually land in the foreground.
I'll give you that, but yeah. I need you to answer me this, Ruhif. This is not even a contentious question. Can you describe? Because I was under the. This is a serious question. I'm not trying to be a smart ass, but they said that I'm trying to figure out the way refraction works and the way it could possibly work on a flat Earth. That's fair. And but I was told that that the cold air with the warmer surface makes light bend upward. I mean downward, yes, making objects appear higher. So can you explain that, like the weatherman and Rumpus and the diagram? Can you explain the way that light disappears with the cold air coming in?
Yeah, so in Pebble's footage, right, you've got this concrete floor, which is obviously absorbing the heat. And then you've got this garage door opening where the cold air is coming in. So what you've got then...
we'll call the concrete floor Lake Michigan, and it's warmer, and we'll call the cold air the cold air. Go ahead.
Yeah, so when you have warm air at the bottom and cold air above, that temperature difference will cause the light to bend upwards. All right, but you've still got to offset that with the pressure gradient as well. So high pressure at the bottom, low pressure at the top will cause light to bend downwards. And there is a like a turning point. So the pressure gradient in the atmosphere is really predictable, very stable.
Yeah. Can you show me a citation of that? Because, like I said, man, I heard that if the light, the cold air comes in over the warm water, okay, then the light bends downward, making things appear higher. Okay. Now you've just inserted something. You know, I'd at least like to see a little evidence. I'm not saying you can't produce it, but I would like to see it, Riv, because
So when they said the cold water, when they said the cold air comes in over the water and it curves downwards, that's cold air below, warm air above. That's an atypical temperature gradient, and that'll just compound or add to the pressure gradient, and light will curve a lot, and that's where looming happens. What was the other question? As to where we get these, how do we know what the density gradient is? I can show you a citation, Philip Sidor, Ciddor. Like if you Google Sidor 1996 refraction.
Yeah, but wait a minute. Wait. If the temperature has all that to play, then there's a zone in our atmosphere, and it's very consistent that the temperatures reach between negative 60 and negative 80 degrees Fahrenheit, right above the commercial plains, and up for about 7 to 10 miles, it goes up to about positive 30 Fahrenheit. It's about a maximum 110 degree, I'd say average of about a 95 degree temperature swing in the way you're describing it. So over vast distances, that would make the sun go down the way you're describing it. And it's consistent too. And every footage I see, there's always that inversion up there. So the way you're describing it, that would make a sun appear lower, especially off in the distance.
The altitude that we're looking at the sun from during sunset is below that region. So we're 35,000 feet and below. During that altitude range, the temperature gradient is fairly stable. It's usually about 6 degrees Kelvin or 6 degrees Celsius per kilometer. Once you get above the the thermosphere, whatever the next level of atmosphere is, then it all changes.
Not hot, melt you, won't melt you. But no, not. I need you to listen to what I'm saying. You don't have to answer me now, but no, you just described what would happen. You just described it backwards. They say the sun lingers on the horizon, right?
Yep.
It's actually set, but it's supposed to be looking higher. But if it's going through that constant atmosphere, that would make it go lower. You just reversed it. The way they described it to me with the weatherman with rumpus and the diagram, you just reversed it by squeezing in warm, cold. I mean, you just reversed it. So you got to think of the implications of that. At least consider them.
The typical density gradient will bend light downwards and refract objects upwards.
Sure.
I'd say one more thing. I'd say also up in that layer, there's no humidity to speak of. And also there's no pressure to speak of. The only really player in the game up there is temperature, and it's a massive temperature shift.
There's still a pressure gradient. So it's not about the absolute temperature.
There's no more pressure to gradiate, dude, is what I'm saying.
Yeah, then nothing
they say
happens
that the pressure down here plays about a 95% role in the refraction. I'm just going off what y'all taught me. Okay, they say that the pressure down here plays about 95% and the temperature's 5%. Up there, there's only about 5% of the pressure left. Okay, so there's no more pressure to gradiate. Okay.
Yeah. If there's no pressure,
at least consider it. Okay. I'll
Can we talk about reality and not what we've been taught about a model over these last couple of years? That's what we're fighting.
Reality. I caught that, dude. That's a good one, buddy. I'll back off.
So who cares about the model that another person taught us that we're finding out is incorrect? Let's talk about what we're actually going through, seeing what many people now are going out and doing.
Diagrams down my throat so much, dude. I gotta,
no one really cares.
From time to time, brother.
Yeah,
No,
Guru have said a lot of stuff, made a lot of claims there. and I was listening to it about this is the pressure gradient, this is the typical pressure gradient. I think it's much more complex than you're saying, and you've got assumptions baked in, as Dave alluded to, that are ball model assumptions. So you've got curvature in there, you've got the sun at 93 million miles, you've got all this shit going on. So if the sun is local, let's take a typical sun, what would this be, a sunset, right? The sun would be somewhere
local. You've got to explain why it goes below eye level.
Yeah, so here's the sun.
Speaking of triangles,
so here's the sun over here at this time, the sunset in like the West Coast, and you can see there is a huge temperature difference between where the sun is and where the sunlight lands for sunset. It's about a 35 degree temperature difference in this one scenario.
When you say where the sun is,
so when we're talking about, let's say
when you say where the sun is,
the sun is sitting over somewhere by Australia, right?
So hang on. You just criticized me for assuming a globe. What are you doing here?
Well, I'm talking about a concept here. I'm talking about a concept. So we know that the sun, it looks like it's somewhere over.
We're talking about what he can actually see.
Yeah. I'm talking about how it looks over Australia, and the light is hitting us here. We're seeing a sunset on the West Coast. Well, between us, and this is true in almost all scenarios with the sunrise and sunset, there is, I don't know, a few thousand miles of space in between where the sun appears to be and our location. And it's going through, in this case, about a 35 degree Fahrenheit temperature difference from where it is, say, down in Australia and where our sunset is happening. And plus, it's got all this humidity over the Pacific Ocean in this case to go through, and another temperature change. So there's a lot of changes, and this would be a very dynamic thing for sunsets and sunrises, right?
No.
Why?
Fatal mistake. When you shine a light into glass at exactly 90 degrees normal, right? So you just point it straight at the glass. Does the light bend?
What does that matter? Just make your point.
Yeah. The temperature gradient is a vertical thing. Going horizontal through different temperatures makes no difference whatsoever. That's not the cause of refraction.
So you don't think that'd make a difference at all? That you're going from one zone of, let's say, a hot zone to a cold zone. You think the light would travel through those mediums exactly the same?
Yeah, you're just shining a light through glass.
Doesn't density cause the light in your model to go up or down, to refract up or down?
Yes, but it's,
so is it going to refract up or down at the same amount when it's going through 90 degree Fahrenheit medium versus a 50 degree Fahrenheit medium?
Again, you're shining it directly at the medium. There's no Snell's law, right?
Yes.
What happens? What happens to Snell's law if you just shine it directly at something? It doesn't change direction.
Snell's law is irrelevant to this discussion because we're not looking into a different medium. We're looking through the dynamic medium of air in a horizontal.
So all your observations are not inferior mirages, not caused by light bending?
It is. Okay, hold on. No. It is caused by light being distorted because the bending happens in a 360 presentation. Okay, so when we look at a house 5 miles away, we don't see that house refracted like a pen in a glass of water. It's refracted in every dimension: height, width, and depth. Okay. So Snell's law is irrelevant to this discussion because we're looking through one medium, not two.
Snell's law is a good illustration of what's happening. It's a macro level.
Absolutely not. Bullshit.
It is a macro level thing. You can use it to approximate the atmosphere. It's not good.
No, you can't. In your world, you might be able to go, it's kind of, it works. No, it doesn't, Riv. It does not.
It does. Snell's law, bit of calculus, and you got a curved line of curved.
Okay, great. So if you want to present a claim that you can demonstrate with your math calculations with Snell's law in an observation? Let's dance.
All right, I'll do that one day.
All right.
Yeah, so I'm not even willing to go as far as saying light is bending. I don't think we should talk about it like that, since it doesn't really bend. You're talking about the change of direction, this whole model of light that you've been taught. All I'm asking is, doesn't it make sense when you're going through different temperature zones that the light that's traveling through at long distances is going to behave differently in those temperature zones? They are, in essence, different mediums.
When you're hitting it at 90 degrees, it does not change direction.
When you're hitting it at 90 degrees, it won't
Can
change
you
direction.
demonstrate?
You're hitting it at the normal.
Yeah. Can you demonstrate that?
Sure. Shine a light through any.
No. Don't tell me. No. I don't want your rhetoric. I want you to show us.
I'm sitting in my study, Travis. What would you want me to do?
Okay, Ruhif. Okay, listen, then be a big boy and take it with a grain of salt that if you can't do it right now, then don't. But my point is, all you're doing is making a blanket statement that you expect us to take at face value, that if you have a perpendicular piece of glass and you shine a light through it at a 90-degree angle, you're telling us that it's not going to bend at all?
Correct.
Okay, well then that's what I'm saying. Please demonstrate that when you get a chance.
If I had a prism in front of me, I could, but I don't.
I agree with Ruhif. With a lens in your camera, that the bit in the middle, the fattest part of it, the light going through that doesn't get refracted at all.
Yeah, but wouldn't that polarize it? Wouldn't that polarize the light?
Oh, I don't know. That's why they're shaped the way they are anyway, lenses.
Yeah, but when you get to the outsides of the lens, you've got an angle that the light is going to be crossing through the lens at.
Right, Mark, though. Okay, so, but what I hear you doing right now, Mark, is changing the discussion to a lens. When Ruhif began, it was just a pane of glass.
Yeah. Okay, well, if you think of the tangent of the lens right at the focal point, the center of the lens, you've got a 90-degree entrance of light going into the lens, and it doesn't get distorted at that point. It's only when you move away from the center of it that you're getting light coming through at angles, and then that's where the refraction would start.
Yeah, light traveling through the same density doesn't change direction.
Ruhif, are you familiar with the expression evaporation produces cooling?
Evaporation, with the whole adiabatic lapse.
Hey, that's my quote for the last 2 fucking years.
Okay.
I want it back, or a nickel every time someone says it now.
I'm vaguely familiar with it, yeah.
Yeah. When something rapidly evaporates, it lowers in temperature. And my understanding...
Sure. Evaporating coils.
Yeah. The surface of water can't be compared to the surface of tarmac or concrete, because on a summer's day, concrete can get to maybe 70, 80 degrees. Gets very hot. But over water, you've got that evaporation just above the surface of the water going on, and you've always got a very cold, a cooler band going across the water because of the evaporation happening at the surface. And so light coming across towards you, light goes towards a denser medium. So there's a dense zone just above the water where light is pulled down into it. And my opinion is that when we don't see the lower part of buildings or boats, I take into all the research that Travis has done, and I accept that. But on a very clear day, we can also see light getting pulled into the water, and so the observer doesn't see it. They only see the 90% part of a building or a boat in the distance, because that evaporation producing cooling is drawing light back down into the water.
I would agree. Usually, especially here in Florida, we see blockage usually. So I would agree, but kind of disagree at the same time, because what they taught me is backwards.
I think Travis has demonstrated maybe half a dozen different scenarios of what happens over water.
I think if you're... There you go. Right, sorry. We're like a 300 millisecond.
Go ahead.
I think what you're talking about with evaporative cooling, and you're saying there's a cool layer, or wet layer or whatever, you do have to take into account all three variables into the density gradient, and that's temperature, humidity, and pressure.
I would be pretty confident that whatever day we're having or whatever climate we're having on any particular day, the surface area of water will always be the coolest.
And then it depends on what
It's
the
hilarious
temperature
listening
gradient
to
is.
Ruhip try and monopolize nature. It's hilarious, bro. Keep going.
Oh, okay. Thanks, Brian.
Well, the evaporation of water happens at the surface, and if evaporation produces cooling, you've got a very thin, cool layer just above the surface of the water that will draw light into it, and an observer across water won't see the lower part of distant objects.
You think that layer would block objects in the distance, maybe bottom up? That
No, if light's bending down.
I almost finished, Ruha.
All right.
We're talking about evaporation layer right at the waters, right at the top of the water, a very condensing effect, temperature change, a lot of evaporation happening, density changes, heat and temperature changes right at that layer. And you don't think that's going to block an object in the distance?
Again, you've got to take all three factors into account. If you're saying that it's evaporating, if it's evaporating really quickly, you would expect a really steep humidity gradient, right? So you have really humid at the surface and less humid up top. That will have an effect of pushing light, bending light upwards. But then he's also saying that the cold air at the bottom and then the warmer air at the top, that will have the effect of bending the light downwards. And then the pressure gradient.
Bending or reflecting, those are loose terms, but we're talking about turbulent air no matter what, right? No matter what fancy words you're putting on it, we're talking about turbulence, basically. And you don't think that's going to block an object in the distance? I'm still waiting for the answer to my very easy question.
All three components have to be taken into account to work out a density gradient.
So should I ask my question again since you started on your rhetoric?
Yeah.
Do you think that condition is going to obstruct objects in the distance?
An upwardly bending light ray will, yes.
Over concrete, but not over water. It'll bend down.
Are you kidding me?
An upwardly bending light ray will block an object in the distance.
Yeah, good luck
There's
with that.
there's no way. If light rays are bending upwards, then how is either a light ray from that object is going to hit the surface or it's going to go over your head?
So it's only going to do it on concrete. Are you agreeing with this guy, Ruhif?
It can happen on any surface, whatever the variables are.
Thank you. So not just concrete. Thank you.
Yeah, if light bends upwards, it can block things.
You can carry on if you
regardless
want,
of water.
but one is saying just on concrete, not over water. You're saying over any surface. I'm agreeing with that. Objects can be obstructed, and if it's a boat and the boat just happens to be on the water, like most boats are, it's going to be obstructed more at the bottom than it is upwards on the boat because of that layer. Correct, Ruhif?
If light bends upwards, it will be obstructed. Yes, by
Correct,
inferior mirage.
Ruhif. And would the bottom be obstructed more?
Yeah, if light bends upwards, it'll be obstructed.
So bottom up obstruction of boats over water.
If light bends upwards, yes.
Thank you, sir. I'm
Thank
done
you.
with this guy.
Very good.
Yeah, so there's a lot of factors involved there, but tell me something. You say that the light won't bend because it's coming at the medium 90 degrees. What's happening in that garage where the light is coming directly across the floor into the camera? How is this situation different? Why is it impacting the garage where we get the inferior mirage blocking the bottom of the object? Yet the light won't be impacted traveling these thousands of miles from where the sun is to where the sunset is happening across a vast ocean.
So your sunset here, you're effectively looking 0 degrees from LA or San Diego, wherever, to Australia, 0 degrees on your flat Earth. These temperature changes over that distance, you're hitting them at 90 degrees. There's no gradient there. You're just hitting the glass, at the normal.
No. So
Again,
how is that different than the garage floor, Ruhif?
Because you've got a vertical gradient in the garage. Vertical gradients cause refraction.
LOL.
What?
Keep going. Don't let me stop you.
Okay. What do you mean by a vertical gradient? So I've got two gradients here laid on top of each other. Do you mean this one that's partially off screen at the bottom? That would be a horizontal gradient, or this vertical gradient. This is what you're talking about, right?
You're talking about a sunset where the sun is at 0 degrees.
Yeah, I know what I'm talking about. I'm asking you what you're talking about.
So put it at 0 degrees.
Okay.
Put it at 0 degrees.
What do you mean put it at 0? Why would I put it at 0 degrees? Why would I put it at 0 degrees? It's way up in the sky.
There's
We
no such
measured-
thing as 0 degrees.
We have
Sorry.
measured the elevation of the
You've
sun at
invented
sunset.
New use of 0. Sorry, Charlie.
Okay.
Put
In
it at 0
reality,
degrees, and your horizontal gradient doesn't
in
happen.
reality, even though we see something on the horizon, like a plane that flies away from us, and it's at 0 degrees, does that mean that the light would be traveling at 90 degrees through here directly to us? Or does it mean that?
Yeah, but now you
No. It means the sun is actually
You
up
had it right
here,
there, Brandon.
and due to
You had it right.
perspective, we see it down here. As
No, you
sun's up
don't see it
here,
down there
due to
due to
perspective, we
perspective.
see
It
it
is
down
down
here.
It is down there. It's at 0
So
degrees.
anyway, even with your thing there, let's just make this assumption that it's at 0 degrees.
Yeah.
So it's going through these
Put it down
vertical
there,
density
your horizontal
gradients here.
gradient is
Why
equals.
is the light not going to be impacted through those 1,000 miles? Because it's hitting each gradient. You think these are perfect gradients at 90 degrees?
You've drawn them as perfect gradients.
Okay. Is that what your contention is? That since it's going straight from one gradient to my eyes through these gradients, it's not going to refract at all?
Correct. Same
Okay,
as shining a
that's
light on a
really
block of
silly.
glass.
That's really silly. So first of
How it
all,
works, Brandon.
it's
How it works.
perspective that's causing it to look lower. It's actually like this, so it's not going 90 degrees. The sunlight would be coming down at you from its position up in the sky. We know it's higher than us because we see it above us at noon, right?
Yeah, this is just your lack of triangle knowledge, Brandon.
We'll get to the triangle thing. So where
I missed the first 15 minutes.
yeah, we'll get
As soon as
we'll
you
get to the
put it
triangles.
to where it actually is, you're hitting those gradients at 90 degrees, and they don't have an effect.
You're skirting the question. Okay. I think that's silly what you're saying. Well, how is that different than the garage floor, though, Ruhel?
It is silly.
So
You're
in the
absolutely
garage
right.
floor, it's like this,
I'm
right?
saying because it looks 0, that it somehow has come down in the sky.
It is 0. It's measurably
As
0.
soon as we prove this wrong, you'll have to claim that that's how I've always said it. So you got a sneaky one, but I don't think he does it on purpose. I do believe he's an honest man, and but yeah, he tries to monopolize nature. He won't even budge when it comes to another possibility.
Okay.
Defend the globe till the death.
So suspend disbelief for a minute, and let's say that we are on a flat Earth, okay? And we see the sun go down towards 0 degrees because of perspective. Just suspend disbelief for a minute.
No, when you say due to perspective, if it's at 0 degrees, it is as high as you are.
Holy shit, man! This is not difficult to understand. So if we
Okay,
saw,
I can draw
hold on,
it.
hold on.
You know this is dumb, man.
This is really
Seriously.
simple.
Triangles are very easy, Brandon.
So you see that?
Here.
You see parroting the cat's triangle argument. That's so pathetic. I thought more of you.
Yeah.
I did.
Hey, can I share my screen quick?
Yeah.
And I can explain it to him with a picture.
Sure.
Okay. This seems super duper easy. All right, and let me know when you guys see my paint here.
Let me just share it for the audience here. Okay, we see it.
Okay, awesome. So you have little guy down here, and he's already given us, flat Earth or whatever he's saying. If you're on your flat Earth, it's at 0 degrees, blah, blah, blah. Okay, so here he is on our flat Earth. I'm not a good artist or whatever, okay? And here, I'll switch to yellow here. Here's the sun. Let's say it's noonish and it's above us. Okay? And we're on the flat Earth. So the sun is close. And it's basically moving just like this around the flat Earth. Okay? At which point here, along its track, is it going to be at 0 degrees to this person?
It never will be at 0 degrees.
It never will be. Thank you. Problem solved.
Correct.
The sun literally never gets to 0 degrees on the flat Earth. Thank you.
And
I
yet,
win.
and yet we measure it at 0 degrees.
No, we don't.
Yes,
You
we
don't
can.
measure it at 0 degrees.
never
You
intersect the
perceive it
horizon.
at 0 degrees, and you call it a measurement. It's not.
What measurement
There.
tool would you like to use to measure the angle to the
It's
sun?
not a measurement. You can't. You can't measure where the sun is because you can't
we
get to
can't.
the sun.
We can't measure it. We can't measure the
No,
angle to the
you
sun.
can't. It's literally impossible for you to measure it.
So let's
Why
this
is
is
it
going to go
impossible?
nowhere because he's never going to understand
Why
this
can we not
argument.
measure
I
the
don't
angle to
think
the
so. Let me just ask it a different way again. What is different from this situation? Let's say it is happening how you say it, and it's 0 degrees and it's going 90 degrees through these layers. What is different about this as opposed to the garage?
What you're showing on screen
Or
is a
anything else we
horizontal
see on the
gradient.
horizon, for that matter, Ruhif, that we see obviously
showing-
miraged and all that. Why would that be different?
What you're showing is a horizontal gradient, so it's hitting different layers head on at 90 degrees.
Holy shit.
That does not cause a change in direction.
Why does
right?
it happen in the garage?
Yes, because you've got a vertical gradient. You've got a hot concrete floor and cold air coming in over the top.
What do you mean
You've
over
got
the
a
top?
vertical
I'm
gradient.
pointing my camera directly at the target 240 feet away, or Pebble is.
Yeah.
Okay, so
You've
that's
got a
0
hot-
degrees,
hot
right?
concrete floor.
That's 0 degrees, right?
That's supposed.
Yes.
So
you've
the
got a
light is
hot
traveling
concrete
at
floor
0
and cold air
degrees
coming
through
in.
whatever gradient is there, right?
Yeah, you've got a hot concrete floor and cold air above it. What's the problem? That's your vertical gradient.
Come on, you're not this stupid. You understand what my question is.
I'm sitting here wondering the same about you.
What is different between that situation and how you think the sun would be if it's going 90 degrees so it doesn't refract? Why is it refracting in the garage?
Because you've got a vertical gradient.
Is this what you call a vertical gradient?
What you're showing on screen with the lines separating the different temperatures going vertically, no, I'd call that a horizontal gradient.
Okay.
So vertical gradient, dense air, or dense or not dense, low, and the other high. Right? Horizontal gradient, hot temperature close, low temperature far.
All right. So this is what you mean, right? You think the sun would
Yes.
be down here since we see it at 0 degrees. It'd literally be shining 90 degrees, the light through this gradient. That's how you think it would be.
Yes.
Okay.
It is a
On a flat
vertical
Earth, don't you
gradient
think
that
that's how it
causes
would work on a
refraction.
flat Earth?
Oh, refraction works on a flat Earth. Yeah, sure. We have density gradients on a flat Earth.
This
That's
is
fine.
pointless. All right. I got you.
Okay.
You're obfuscating. You're playing a game. You're
Yeah,
playing
I'm
word
obfuscating.
games. Let's go to triangles.
Okay. Refraction is caused by vertical density gradients. Catch us all later.
Yeah. No.
Oh,
You're
yeah,
not
do
going
you
to
wanna-
stick around?
do you wanna talk about-
I need your help. I need you to tell me
Oh.
how to measure the distance and the angle, the sight angle to something, and use trigonometry to do that.
All right. I'll give you
Can you
10
tell
minutes.
me how to do that?
What was the question?
Can you show me how to use trigonometry to measure the angles to something?
To measure the angles?
Yeah. If I measure the angle to it, how can I use trigonometry? Like Polaris.
What sides of the triangle do you know?
Okay, let's say Polaris was on flat Earth.
Yep.
Okay, I know the side angle to it, right?
Yep. What's your side angle?
Cosine.
45 degrees, let's say.
45 degrees. All right. Do you know either the height of Polaris or the distance to Polaris? Assuming it's above the North Pole.
We're assuming it is above the North Pole.
Yep. Do you have the distance? Or the
From
height of it?
45, let's just call it 3,200.
Heliocentric map.
I can't
3,200
remember exactly
miles.
what it is. That's pretty close, though.
Nobody has those numbers because you can't check it.
I know. It's just.
That's always my point. You can't work it out because you don't know the distance.
Exactly.
Really?
And here's the problem. Here's another problem.
Yes, really. In
on the
reality,
model, the
no
latitude-
one has ever been able to verify the distance or height of Polaris because you can't go there. So there's no way to
No, I mean-
verify it. So yes, really, in reality, nobody knows those numbers.
All right,
No, I thought the
Ruhif, you got
question
all
was
the
you don't
stuff
know
you
your
need.
distance.
So how are you going to figure out?
Yeah,
The
one
rest of
second. Did someone tell you you don't know the distance to the North Pole?
Yeah, but the problem is it's on a globe
Yeah.
model.
No, to
dude.
Polaris.
No.
The
No.
latitudes are
to the North
parallel on the flat Earth. The longitude should be parallel. It's backwards. So if we use the distance supplied to us, it will come up to match your model.
But you don't think you're capable of sort of verifying distances?
Let's not get wrapped up around this. Let's get
another kind of
Yeah,
model.
okay.
let's get
Let's
back
just
to
do
the
it, right?
subject and
No.
tell me how you would calculate this, just so I can make sure that we are talking about the same thing.
Yeah, right. So simple trig, right? You've got a 45-degree angle. You know the adjacent side, 3,200 miles. You want to find out the opposite side. So you use the tangent formula from SOHCAHTOA, TOA. So tan 45 equals x over 3,200. And then you just rearrange that to get x equals 3,200 times tan 45 equals 3,200.
So I'm a dumb flat earther. I'm going to use this triangle calculator here instead, right? So
You look like
90
Riley.
for under the North Pole. I said 3,200 here, right? We'll call that 3,200, and then this is 45, right? So there we go.
Yep.
And all that SOHCAHTOA and all that shit that you think is important to memorize is all contained within this calculator. I'm doing this right? And I calculate.
I think so. Yeah.
And it says that the height of the object is 3,200.
Very good.
And the hypotenuse is 4525. Is this correct?
The height, yes, which is side B, 3,200.
This is how you believe that you should calculate this, right?
Yes.
With a
Do you
right
have any
angle.
other?
Thank you. Don't worry about refraction. We're not worried about that. So I want to apply this to something else. And what I want to apply it to is the distance that Mage 2 can see. Are you familiar with the Mage 2 footage?
Not really.
You're not. It's Mr.
No.
Sensible's balloon footage?
I heard that he launched a balloon, but I've never watched anything, so no idea.
Yeah, he launched a balloon. He launched a high altitude balloon. It got up to somewhere around 36 kilometers. And that's about the number we're going to be dealing with. And the footage looked somewhat similar to this. So could I use the height of the camera and the angle of the lenses to the ground to also calculate what I see on the ground and how far I see? I think I can.
You can, but are you going to assume a flat Earth or a globe?
I'm going to assume a flat Earth.
And where is level? Like, how are you getting level in this?
That is a good question. So I've got two main assumptions. One is that the vertical field of view of this camera, the front-facing camera that they're going to be using, is 26.66 degrees.
Okay.
The second assumption is when the cameras are horizontal, the orientation of the horizon within the front and back camera frames is nearly the same. And you can see this
Sorry,
when the
orientation of the
object is
horizon.
near the ground, that in this one on the left, you've got the horizon
Yep.
kind of at a slope. It's right around midline, kind of evens out there. And then you've got about the same thing pretty close over here on the wide
but
cam.
Go read back that last little paragraph on the screen there a minute ago.
I really hope Conspiracy Cats is watching because, Brandon learned triangles, dipshits. Go ahead, sorry to interrupt.
That's
The
all right.
orientation
So when
of
the
the
cameras
horizon
are
within the front
horizontal,
and back
when the
cameras,
camera's
no, it's
horizontal, when it's looking out at 0 degrees, right? The orientation of the
sounds like
horizon
something.
and the front within the front back cameras are nearly the same. So this is what it would look
That
like roughly
sounds
when it's
like an
horizontal.
assumption.
They're about at the same level.
That sounds like an assumption that horizon rises to eye level.
Nope,
Is that an
it's
assumption
not.
that
Nope.
horizon
Does it
rises
say
to
that?
eye level? I'm trying to interpret what it means.
Yeah, all this means is they didn't have a gyro or anything to tell us when the camera is horizontal. So I had to figure
So how
out
do we know
because
when
this
it's
one
horizontal?
looks like this one. It's about horizontal. This is when it's horizontal.
Yeah, but how do we know it's horizontal?
That's what I'm telling you. When they are about the same, such as in these two cameras, this is the front, this is the back. It's horizontal.
When the horizon is in the middle?
When the horizon is in the middle of the frame, yeah.
Okay, so it is an assumption that it rises to eye level.
No, it has nothing to do with rising to eye level. This is just about when
Then
the
it's
camera
not
is
gonna be in the
horizontal.
middle.
When they both look the same, the front and the back, when they're both at approximately the same level, the horizon, Doesn't have to be the middle. It doesn't have to be eye level. When they're
Right.
both at the
Okay,
same
front
level,
and back.
it's horizontal.
Front and back.
Yes.
Okay, understood. Understood. Thank you.
Okay, you're welcome. All right. So, sorry, I got a little heated there. I could have clarified it better. All right. So this is.
Oh, no, I missed the words front and back.
Yeah. Oh, okay. All right. So here's just a bigger shot of what we were looking at when the two little pictures of it being horizontal. This is the picture that we're going to work with to determine the distance to what we perceive as the horizon, which you'll see where I'm calling the horizon when we see here. I actually think it's further, but we're going to be generous today. And this is taken at 36.2 kilometers. We're going to use just 36 kilometers for ease. So we're going to do a little rounding, but it won't make that much of a difference. So these two are approximately at the same level. The camera appears to be horizontal. Would you agree?
Yeah, close enough. Yep.
Okay. First thing we're going to do is we've got the front camera. I'm sorry, what's that, Ruha?
It doesn't rise to eye level then, right?
Yeah, that's right. It doesn't rise to eye level, correct.
Excellent. Very good.
Yep. So here's the front camera field of view. We've got 26.66 degrees. That's what we're seeing. So that gives us this angle right here, right? We're going to use that angle. Here's the ground. We're going to use this intersection of the bottom field of view and the ground. And that's going to essentially be this right here, the bottom of this field of view. Right?
You said vertical field of view, right?
Yep, vertical field of view, yeah.
Vertical field, okay.
Yep. So the bottom of the vertical field of view is this, and that is represented by this point. Okay.
Both of the cameras are pointing down. They're not pointing horizontal.
Hey, I'll tell you
They're
what.
not
Not right
pointing.
now. Not right now. You can listen in if you want. Not right now. Okay.
Ah, dear. I heard you mute him.
I had to mute him because, well, I'll never get through this.
I know, but he's given it a very important fact, right?
Yeah, we've already talked about that, but that's an assumption. So thanks for being 5 minutes late, Rumpus.
Yeah, I know, but now everything is going to be meaningless from here because they're not actually pointing horizontal.
The cameras are pointed down.
Yeah, so they're not pointed horizontal. This idea that they are both, the front and back cameras are the same, have the same horizon, doesn't matter anymore. They're not horizontal.
How do you know? So let's continue. We're going to go with that.
Well,
stick with that
you said
assumption.
you've had
If
this
that
discussion with
assumption is
Rumpus.
proven wrong, then we'll address it at that time. But do you have any evidence that that assumption is incorrect?
The fact that Rumpus just said we've talked about this. Sorry, you said you've talked about it with Rumpus, and Rumpus is pretty sure they're not pointing down.
I have not
makes
talked
this
about
pretty
this with
meaningless.
Rumpus. Thank you, though. So
Well,
that was a nice bit of obfuscation there on Rumpus's part, and you're going to continue it.
Well, I'm not going to give anything now because I have to check with Rumpus. Like, how does he know that
now
they're
you're
not?
going to bail. Okay, you don't want to see me use triangles.
I would love to see you use triangles, then I'll bail.
Okay.
Use triangles.
Fantastic. So you can stay quiet if you want. I'll talk to somebody else. Hey,
I'll even
who
mute.
wants to be the other participant in this since Ruhif has obfuscated his part in this back and forth? Anybody? All I need is somebody to nod their head and say, yes, I understand, or shake it.
I'm not so bad for that. I'll go through it with you.
Fantastic. Thank you, Jimbo. Okay, so as I stated, the bottom of the field of view is this point right here. We obviously know the height, which gives us this, which would be this side of the triangle right here. So we've got everything we need, essentially. We cut this field of view in half, and it's 13.33 on each side of that. That gives us this internal angle, which is the same as this angle down here. Okay, so we've got it lettered A, B, and C. No, get out of here. Sorry about that. The cat tried to sabotage the presentation as well. Oh, gosh. Okay, so we'll go to the next slide. So this is 90, obviously. So these two angles have to add up to 90. We know this is 13.33. So this has to be 76.67. Now we've got three angles. We've got a height. Plug them into the calculator, and we can get our distance to the bottom of the field of view, which is C. That is 76.67. You with me so far, Jimbo?
Absolutely.
All right, so let's do it together and plug this into this triangle calculator, which is really simple. So this side, the height of the camera is 36. This angle is 90. And let's see, how did I do this before? This angle over here is, what is it? 76.67, right? Oh no, this one's 76.67. This one. 0.67. So we got 76.67, 36, and 90, right?
Yep.
Oh, I have 4 because of that one. There we go. We get for C, the distance to the bottom of the field of view of the camera is 151.9. So this spot right here in the field of view is 151.9 kilometers. We're going to add another triangle, and we're going to cut the field of view from the mid frame in half. And we're going to cut the space in between the bottom of the frame and the mid frame. We're going to cut that in half, and that gives us 6.66 degrees that we need to add to get the angle to that point on the ground. That's going to extend out. So it's basically the blue line, the blue dotted line here is 76.67 plus half of mid frame to here. This extends out there off screen. So that'll look like here. All we've done is cut this in half. Middle frame, which is horizontal, and to the bottom. That's our 83.4 degrees. With me? Jimbo?
Yes, indeed.
All right, so this spot on the ground, or the clouds, close enough, is 83.4 degrees. You continue that out, cutting that in half and adding the amount of angle each time, we get 86.7 for this green line, 88.3 for this pink line, 88. Oh, I got a typo in here. 89.2 for this one right here. Let me just correct that. So if somebody takes this off of here, they'll have the right thing to bash me over the head with. All right, 89.2. And that's about where the horizon is. I took out the stuff that looks about, you know, you could say that's a horizon. That's what they think the horizon is, right around there. G, 89.2. Does that seem fair to you? If you were going to say this is a hard horizon, an actual horizon, does that look like a fair
Where is
spot to
zero?
put
Where's
it?
90 degrees?
I'm not talking to you.
Where's 90 degrees?
I'm not talking to you. Jimbo, does that seem like a fair?
So much
You just
for
drawn a scale,
promising
and your
to
scale
mute
doesn't
yourself.
match your assumptions.
Thanks for promising to mute yourself, Ruhis. It was nice.
I'm
of
still
you
watching
while
that.
it lasted. I'll cut out now.
So where's zero? Or 90? Where does 90?
So anyway, Jimbo, does that seem fair to you? That 89.2 degrees for G?
Yes.
Okay, good. 0 is under you. I just did it from 0 to 90, so 90 is the horizon in this. Okay, so what we've got here
0
is
degrees
we've
is
calculated
apparently
the
the
distance
yellow line,
using
right?
trigonometry. You don't want me to get this out, Ruhif? We've calculated the distance to this apparent horizon using trigonometry. And using this method, surprisingly, I was surprised by how far it is. It's 2,578 kilometers roughly to this apparent horizon. That's a long way. So I had to go and I had to look at the Earth curve calculator and say, wow, does that seem like it matches up to a ball model? I don't know about that.
So, miles and miles of curve missing.
Let's take a look at the Earth curve calculator and see what this very simple Earth curve calculator, just to get a rough idea, what we should see. Here's our 36,000 meters. I put in 2,500 just to put a target in because that's our supposed apparent horizon distance, 2,500 kilometers. And what I get is the horizon is only supposed to be 678 kilometers away. And that the target hidden is, ooh, that's a lot. That's a big number. That's 255,000 meters. Seems to be something wrong, but we use trigonometry So it has to be right, right?
That was 120 miles of curve missing there.
2,578 kilometers to the apparent horizon in Mr. Sensible's Mage 2 footage. Thank you, Mr. Sensible, for proving the flat Earth. I much appreciate it. Triangles.
What does the yellow line represent in the middle?
What yellow line?
In the middle of your screen.
Are you talking about this yellow line right here?
I can't see your cursor. At the yellow line that intersects 36,400.
36,400. Oh,
It's a
that's
yellow
just
line,
a
right?
string that they put in front of the camera to show the distortion.
Right.
Yeah.
So where's eye level in this?
This is the center of the frame.
Where the camera is.
So I didn't ask where center of frame was.
Yeah, this
I'm wondering
is how
whether that-
what we would
I'm
say is
wondering
eye
whether that
level is
string-
the center of the frame right here.
Yeah, that's just a wrong assumption. Center of frame is
Well,
not eye
of
level.
course it's a wrong assumption. Now go get me some fucking evidence that it's a wrong assumption.
Okay, I'll point my camera up into the fucking sky. Is the center of frame eye level?
This is horizontal.
Is it?
This is the horizontal line. The camera is horizontal. This
Pretty-
is looking out
pretty good
at
at
0
that.
degrees,
This is why you need a
Ruhif. Do you have a substantive problem with any of the
This is
trigonometry
why
I've
you
done? Do
muted
you have
Rumpus.
a substantive problem with any of the trigonometry I've done?
Oh, I haven't checked it yet, but I have a substantive
Well, you saw me
issue
do
with why
some
you
of it
muted Rumpus.
online. I mean, this is really tough
Only
stuff,
you're
right? You don't need
troll
to
and
fucking check it,
interfere.
Ruhif.
He's only here to troll, to, you know, gaslight, to do his normal stuff. He wasn't listening to you do it.
Hey, Ruhif.
He certainly didn't mind
I
interrupting. but-
literally stopped caring about your trigonometry when you didn't actually demonstrate that these things were actually horizontal.
Of course you did.
Yes.
At first you
Prove
agreed.
that they're
Remember when
horizontal.
you said, yeah, oh, yes. That seems like a fair assumption. That
Yeah,
is
but it's not.
horizontal. Down on the ground, it sure the fuck seems horizontal, doesn't it?
But it's not.
But when
Rumpus
we get
says
up in
they're
the
not
air, somehow it's not horizontal anymore, right?
Why won't you let Rumpus explain why they're not horizontal?
Because
You
Rumpus
have to prove
is
they're
a
horizontal.
flaming idiot.
All right.
Do you? Why
that's
are you
accurate.
okay
That is
with
accurate.
this
He is.
assumption here? But then when you hear the numbers, you got a
Because it's
problem.
an assumption. It's an assumption that they're on the same plane, and apparently they're not. And that will throw everything off.
I'm curious why Mr. Sensible would not have had those cameras horizontal.
I don't know.
That,
I have
that would,
no
no,
idea.
I'm
about
not
his
saying you would,
experiment.
Ruhif. No, get me. No, hear me. I'm not criticising you in this. I'm just saying, if I was going to send, a balloon up that height, what meaningful result would you get? Like, you'd get more from having them horizontal, because that would give you more of a point of reference to gauge horizons and whatever from. To downward angle them or upward angle them, what would be the point of doing that? I know you
It
can't
might
define
just
his
be
thoughts, but it doesn't make sense to me.
It might just be the base of the camera might be, not perfectly flat or what. I don't know. Like I don't know about this experiment.
Yeah. Well,
But
at
if
least I
Rumpus
did
is
the
saying-
trigger
I'm not
right?
criticising you. I'm just commenting.
Yeah, I know.
I'm not criticising you, man.
You can criticize me like it's a flat Earth debate.
Brandon,
Yeah, but I'm not. That's my point. I'm not criticising.
Yes.
I'm just
You're
saying,
good.
like,
By the way, this analysis is open to criticism.
I'll
I have
probably
no
watch it
problem
back
with
later.
it.
And,
If anybody on this
criticize
panel
it.
has a problem with this, that's why I listed the assumptions.
Yeah, we'll watch it back later and make sure your maths is correct and everything.
Okay.
I'll do
Before you
that.
leave, this is Ruhif. Before you leave, this is Rakia Life. I just wanted to thank you for the honesty earlier about having that small band of temperature difference right at the water level that y'all were talking about, pressure difference, heat exchange, evaporation, create an atmospheric condition that would obstruct bottoms of boats. Hence the reason, or one of the reasons, that we probably get bottom up obstruction over distance. Thanks, man.
All good. Yeah, upwardly bending light will obstruct objects bottom up. All right, catch you guys later. I'll watch this back later and check your maths,
Sure
Brandon.
thing. Just one
All
more. Just the headline before you go is Mr. Sensible proved the flat Earth 2,500 kilometers to the apparent horizon in his footage. Have a good night, Ruhif.
Cheers.
And I used trigonometry to figure it out. Don't forget about that, Ruhif, which you said was very difficult and made everybody think is very hard to do. Okay.
I'm glad you learned triangles. Do we have anybody that sent a balloon up that knew what they were doing and actually had like a level or a gyro on it or something so we could tell when the camera was level?
Yeah, and has anyone ever seen crepuscular rays that, you know, curve up after and form like fish hooks? Because, you know, if light bends upwards at some point while it's coming down, nice crepuscular rays, how come we don't see it curl back up and reflect upwards from this refraction and form fish hooks almost? I wonder.
I don't know, but look at this position of this. Every time I see these balloon footages, I go, dang, the sun seems like it's too low. You know,
look at the hot spot underneath the sun, for heaven's sake.
I mean, if the guy couldn't concede the fact that a sun making a circuit above the Earth is never at 0 degrees, then he obviously isn't looking for an honest discussion. I mean, it seems pretty simple.
Well,
like that's a very simple concept to understand.
Well, that's why I got so pissed off.
Just because it looked like it was at 0 degrees, you can know that it wouldn't ever be there.
Please listen to these words because they're important. 0 is not a number. When you see 0, even in angles, it's your origin of the angle. There is no angle before that. Like on a timeline, number line, what people call the 0, it's not a 0. It's your origin. O for origin. Even though it's used on a number line.
No, it's 0 just represents a lack of something.
It's still an origin. It's not a numerical value. It's not a number. It's an origin.
I want to point one thing out about this. So I chose an somewhat arbitrary, because we don't know where the horizon is in this footage, which was my original criticism when his minions started saying that they proved the sphere Earth with the 20 millionth balloon footage to be put out. But if you look at this, I changed the colors just to try to see how far you could see or if you could see anything in the back. When I look at this visually with my eyes, and that's all we can do with this footage pretty much, I see the land go further than I gave it credit for in this analysis. If I were to really push the envelope, I would push that apparent horizon back, not forward. So I gave them the benefit of the doubt on where the horizon is. And look at this. Does this not look flat? Just look. It looks fucking flat. There is a circle in view. We've talked about why we see circles. Let me go through this one more time. There is a curvature. This is a giant circle I staked out around me. And I took pictures from a camera in the center. As you can see, the higher you get, the more curved you see the circle on your horizon. Oops, I got the wrong ones here. 28 inches, 38 inches, 50 inches, 61 inches, 82 inches. This curve that we see, not curvature, curve, gets bigger the higher up off the ground we get. If I was right on the ground, it would look like a straight line, and I'd have to do something stupid like ballers do. And I'd have to compress this photo and then tell everybody that I saw a curvature. Here, let's do that just for fun on this. Let's do that. Oh my God, would you look at that? I found the curvature.
You found it. Pack it up, boys.
All right. Anyway, I've been talking for a long time. What does anybody have any feedback on this presentation? Because I'm literally open for feedback. Any thoughts? I know it's kind of a little abstract. Since
do Pandora. I'll say you left yourself open for some nosebleeds, but you know we know the facts. You know what I'm saying?
Yeah.
And just a little note, even that calculator page, they left it out probably because it's so taut. Is the ideal triangle is the 3-4-5 triangle, the right angle triangle. And that's the rest of the math for triangles is based on that, the isosceles, scalene, etc. So, and again,
Brandon.
0 is your origin. It's not a number.
Yeah, Brandon, I would say that you're really sorry, Jimbo. Go ahead.
I'm done.
Yeah, Brandon, I would just say you're really good at what you do, man. Putting that together. Like Rakia said, your presentation might leave your chin open a little bit, but that's part of it. But just overall, that was awesome, dude. So cheers. Thank you.
Well, all they got is lame obfuscations, distractions, straw men, the same crap they've had forever. It's just easier to shoot down now.
Well, all they're going to do is just say that the camera's tilt. That's it. There's no way to prove that it's horizontal. So that's all they're going to do. Oh, the camera was tilted. Mr. Sensible will say, well, the camera's tilted and actually we calculated it this way. So this is open to interpretation, but yeah, it's too bad they didn't put something on there, like Jeremy said, to tell us when the camera's actually horizontal. But
well, let's just go on top of that real quick. I learned something about triangles today from Brandon Toy.
Really?
There you go.
Oh,
yeah.
I'll be darned.
I mean, just woo.
That's not saying
That
much.
could actually be kind of scary.
Did you learn that they're boring? Is that what you learned? No.
No, I learned they're useful. Actually, I never even thought about taking.
No, they say hindsight is 20/20. They say hindsight's 20/20. So now looking back, conspiracy cats wasted his whole dumbass debate, calling Brandon out on understanding triangles.
Exactly.
Yeah, I'm taking some flack in chat, but that's okay. You guys
No,
don't
I never
like
thought
this
about doing what
analysis, huh?
I never thought about doing what you did there, Brandon, by taking the half angles and trying to get the distance to that photo horizon, right? That was great, you know.
Well, yeah.
We know it's far off in the distance, right? We know it's very far, but you calculated it with using triangles. Now it's badass.
No, I'll tell you what I actually think. I don't think it's that far. I mean, it doesn't look that far in the footage. But if you use this method, if you use trigonometry, straight trig, to calculate it, that's what you come up with. I mean, if you look at this footage, I'll get a clearer picture up on screen. Man.
I can add too that, like in forestry, you have a little tool that measures this angle, okay? And what you do is you use it to measure the height of a tree. Well, you can't climb every tree and drop a tape measure and say, well, this tree is 103 feet and 2 inches. What you do is you measure a specific distance from the base of the tree, you measure the angle to the top of the tree, and you do 3, 4, 5 triangle calculation, and you get within an inch or so of every tree. It's that accurate. So when they do the sun, the navigators, sailors, and they've been doing it for thousands of years this way, they calculate the same way we calculate for the tree. The sun, they calculate at 32 nautical miles wide, and the distance above on that horizontal span is 3,200 miles. And they navigate the 7 seas with the sun 3,200 miles up and 32 nautical miles across. And that's the end of the navigation story. And they calculate 600 square miles on a plane to navigate from point to point with the stars. And again, they use the same thing, 3, 4, 5 triangles, reading directly down from whatever star they're looking at. They don't even have to know the damn name of the star, just the angle. They can choose anyone that's appropriate about 15, 20 degrees over the horizon. You don't even have to know what star you're looking at. So
I would say looking off into the distance, Brandon, like you're saying, like you wouldn't say it's 2,500 miles or something. I look, if it's flat, it's flat. Now we are looking through a phenomenon also, whether we're at altitude or on the ground, we're looking through the phenomenon of air, ether band. So, right, we can't actually see, especially in the 2D picture, all the way through it. However, when you did the curve calculator thing there too, saying, well, if it is this far, there should be this much drop. Well, the balloon is only 6 miles, 10 miles high, whatever it is, right? But there's 121 miles of drop. You know, it's like just in a logical sense by watching your presentation. I can see that I don't see 121 miles of drop, but I do see very, very far into the distance. I just get blocked by that last shallow angle part off in the distance. That's all.
Yeah, that's what it looks like to me, is you just can't see further than that point. But I don't know, 2,500 kilometers is a long frickin' way.
Get that
What,
flat Earth
1,300
money.
miles or something? It's not. It's like half the U.S.
Thanks, Bill Gates. And Bill Gates donated $10. He said, "Get that flat Earth money." Yeah, 2,500 kilometers is, how many is that in miles? I'm not good at converting.
1.6. Yeah, 1 point divided by 1.6.
2,500 divided by 1.6. Yeah, 1,500 miles from 36 kilometers.
Yeah, that's only 3 states.
Dude, that's
Roughly.
a long way.
Western states.
That's only, you're only,
Yeah.
what, 5 miles up?
Rough airplanes fly at 36,000 feet. I don't know, how high does balloon go, to 100,000?
It's 36,000 divided by 1.6. Will that work? Or is
Yeah.
it, oh, that's feet. Yeah. Hold on. It's 16 something. 90, I think.
16 miles, roughly.
Yeah. 16 miles? Hold on. 36 kilometer. I'm just going to type it in because I don't want to think about it that much. Let's see here. Yeah, no, it's 22. It's 22 miles. So,
yeah,
22 miles up, seeing 1,500 miles?
Mm-hmm.
I don't know, man.
If it's flat, it's flat. You would potentially be able to observe that. If it's curved, you definitely wouldn't see that expanse, I think. But
That's a lot of shit to see from. You're not talking about very high up in the sky,
We
22
can only
miles.
see as far as the atmosphere allows us.
Yeah.
We can only see as far as the atmosphere.
Yeah, it's too bad there's all these clouds and stuff that you can't really see the ground. Now, he did have a mapping of like these cloud areas, but you know, I was thinking about that. It didn't do you much good because this is all like just white area out here, right? There's just nothing you can see.
That's staying up to 1,000 with infrared, and that was from, you know, probably like 50,000 feet, like 10 miles up. So who knows? Maybe it's possible.
Maybe.
On a flat surface, it should be possible if you can cut through, like Brian just said, the the medium that's not allowing you to see that far. You know, air, everything we're fucking with right here, the ether band. You know, and what else? I was just gonna say something. If it was curved and you got your field of view, vertical field of view at 26.6, right? Of Sensible's camera. Right?
Yeah. Yeah, it's 26.6.
If it was curved from the point just below that his balloon, and it curved exponentially away, right? You there's no way his string lines would be like that, in my opinion. Right?
Well, I mean, at sea level, we're 6 feet tall and we see 3 to 6 miles away. That's about 3,000 times your height. So keeping that, you know, ratio the same, you know, 3,000 to 2025 is about 12,000 miles, give or take, something like that.
Yeah, maybe.
Well, 8, something like that.
But, you know, yeah, the atmosphere plays a huge part in it, too. I don't know. I just don't know if it's possible to see that far. That would be like seeing across 2 or 3 states, right? How long is the UK?
Wide, 300 miles maybe. But let's say Wyoming is let's say Wyoming is it's square. You know, it's 400 miles east to west, roughly, or maybe 500. Right? So 3 Wyomings is all you're looking at. It's not. It sounds far, but if you're that high, why not? If it's flat, and that's actually what they're showing. You know, on Dwayne Kellum's videos and all, you know, Sensibles is you see over distance. You're not looking down over a curve at all in any direction.
Right. Yeah, you do see it pretty far in some of his footage. That's true.
It's going to be really small and unresolvable, but looks like we can potentially see up to there without anything, you know, in the way or whatever.
Or falling away. Right?
Yeah.
Or dropping over a curve, you know.
Somebody asked what's happening to the horizon behind the camera. So this is what it looks like. They had 2 cameras back to back. This is on the ground. So I went over this quickly, but it was kind of obfuscated. So this one points this, you know, they point opposite each other essentially.
Make flat Earth great again.
So we live on a camel.
Hey, Donald Trump just donated to the show. $5. Thanks, Donald.
Sweet. Make America great, brother.
Says make flat Earth great again. All right. Thank you very much, Donald Trump.
I forgot.
Yeah, well, we don't know when horizontal is. This was just my best guess at it. It seems fair. I don't know what other assumption you could make, but we'll see what they come back with. Okay. Well, that's that, unless you guys got anything else on that. No?
I don't have anything on that, but I have a question or a topic or
I got
whatever.
a balloon. Oh, sorry, go ahead.
There's a couple of things that I guess we just kind of like let go or just allowed earlier when he was talking about light. Is there any way to verify that one, all light is the same, and two, that light itself even has a direction?
Well, the only ways that I know of that we use to do that is similar activity. We need to see if light travels the same, you know, and or seeing if it mixes without, you know, settling out or whatever, if it was like a substance. But different wavelengths of light appear to have different electrical capacity. If you look at the videos of Theoria Apophysis, aka Magnetic Fester, as he's called by his detractors. And so it does look like even different colors of light have different electrical, you know, capacitance, different wavelength, leading to a different angular resolution of the light. If you're talking about the angular resolution formula, stuff like that.
Polarities.
Well, I think Brandon called him out when he was saying, Ruhif was saying that, you know, if I shine light perpendicular to a surface, glass, a pane of glass, you know, there is no refraction, distortion, blah, 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 right? And Brandon called him out and kind of said, well, the sun is actually over our head. We are looking out over 90 degrees horizontal. So his whole light thing kind of broke apart there in my mind about where light's coming from and, you know. But it kind of just got washed.
But the idea that it has a direction, like I can understand like why we would have that concept, because you know we turn on the, like if we turn on the laser, in our minds the light is going from laser pointer to wall, okay? But we don't ever actually see that or observe that take place. What we observe is we press the button and the light is at the wall. Okay, so the idea that it has a direction, like I don't know if that's actually accurate. I don't know if light works with those kinds of rules, right? Like the idea that it is moving from the laser, like the source, is moving from the source to the thing that you're lighting up. We went along with it, and I understand, like, I guess if you want to just continue the conversation for a different point, I can understand just letting that go. That's fine. But I'm just, now that we're kind of moving past that topic and we're moving on, I'm wondering, do we actually have a way to verify that light has a direction?
My point is, real quick, Brian. My point is to Bob that
We
they
must
always try to
flatten the
correlate
curve.
laser light with
Together we
sunlight,
can do this.
right?
Together
Daylight
we
with
must
laser
do
light,
this.
like all
Thank you.
forms of light with a laser light. That's their always go-to. So,
Well,
sorry,
to
Brian.
verify that light.
Thank you, Justin Trudeau. Much appreciated. $5. We must flatten the curve together. We can do this together. We must do this. Thank you. Lots of big names in here tonight to get a look at my triangle work. I really appreciate it, Donald Trump and Justin Trudeau.
When Jimbo answers, I'd like to hear that too. But the only way to tell if light travels is if we could track the beams of light or whatever as it goes from side to side and see if it goes, to the destination, stays, at that location and then can come back. Like if we could track the photons or whatever. But if it's like a wave of water, or ether, then all you're seeing is the waving, undulating activity of the medium, which is everywhere while it really stays in place. And the only thing that's traveling is the wave, which can't be tracked as far as I can tell. It doesn't have anything physical that can travel for tracking other than the wave activity.
Hey guys, I'm trying to figure out how would that even work to have the cameras pointed down at the ground. So let's say they're both pointed down. I'm trying to figure out if this is just a bullshit excuse in and of itself.
Well, if it was pointed down, it wouldn't hit the target. You'd have to walk it to the target, and you'd have to hit the hump of Earth curvature while it goes over the target for there to be a curve.
They're gonna hammer you on this, Brandon. This camera pointing down thing.
Oh yeah. No, I know this is where it's going to come.
That's why I immediately asked, has anyone done this? That's send it up with like a gyroscope so we can see when the camera's level.
Yeah.
But
or something.
They're going to have to say that one of the cameras is pointing. How would this work? So you've got the horizon in the center of the screen, right? Am I still sharing my screen?
We'd have
center.
to go audit Mr. Sensible's and apparatus and see and verify for ourselves, which we can't do.
No, I know. I know. Yeah. But I'm just trying to figure out if this is just a flat out bullshit excuse, or if there's merit in the idea that the cameras are pointed down. Would they both be able to have the same view of the horizon if they were both pointed down? Or could one be pointed down? And
good point. How would you ever get? Oh, maybe.
Well, think of two back-to-back cameras. So I've got two back-to-back cameras, and let's say the horizon is in the middle of one. It's definitely going to be in the middle of the other one, right? If it's perfectly horizontal. So if I tilt one, now that one doesn't have the horizon in the middle, but the other one does.
Yeah, but the horizon, I think it could match. Maybe depends on how much they had them angled down.
Yeah, if you use two cameras, it can be sketchy. So I brought this up before. What if you used a mirror? So a perpendicular mirror, perpendicular to the camera. It's got to be verified. Your camera's shooting out one way, but you cover half the lens with a mirror, so you actually get to see behind you also, right? That would kind of be the only true test if we could verify it that that mirror was perpendicular to the lens of the camera.
I don't think you could do that up at the elevation. That to me, in order to have both your foreground and your background, what's behind you and what's in front of you, I think that you would have to have
There'd
the
be
mirror
no
out.
zoom though. There would be no zoom, right, Travis?
Well, my point is that if you just start out the camera at 35 millimeter, which is basically what our eyes see, right? You still have to line those two things up correctly. And I'm just saying, I don't know what that distance would be from the camera lens.
I would just kind of wonder what the mirror would show. Yeah, with the camera shot. Go ahead. Sorry.
Let me say something real quick. I got I heard somebody, I think it was yesterday, talking about the balloons and speculating the price of them and all that. And I bought a few of them. I'm down to one functional that I haven't used yet, and it's a high altitude balloon, and it was about $30. But also, I just got my third camera. The two of them are kind of crappy, but the third one is it's the GoPro. It's decent. I got it for a good deal. But I got the gas to launch it. I have the balloon, and I have the cameras, but I don't have a gyroscope. Also, I don't have a tracker. So I need to study into this, but it's on my list of things to do. So I'd love to have go into depth about it one night, man. But unfortunately, I'm about to have to drop here in a few minutes. But I'm game to talk about it. Does anybody who's got any other ideas? I'm always up for ideas.
If it wasn't so turbulent up there, I mean, you could float your camera in a cooler on a piece of styrofoam, right? That should be level. You know what I mean? The cooler of water. I mean,
a little bit of water to water. You know, if we assume that water lies level, we could use that as a water level. You were saying?
yeah, something like that. You know, I mean, these are far-fetched, and I'm never going to do it, but you know.
Thank you, Nancy Pelosi. Much appreciated. Thank you, Nancy Pelosi.
Plus, it's super turbulent. A lot of Dwayne Kellum's shots are, you know, blowing all over the place. And so, sorry, Travis.
Well, I just think that this discussion in terms of getting this elevation is not the focal point. What I was thinking about earlier when the whole inferior mirage now is going to get poo-pooed by saying, oh yeah, we've said that's the inferior mirage has always been an obstruction, so what's the big deal? The point of focus now, I believe, is I think that we can actually have a discussion in this area. So anybody, please, put your thinking cap on. But if you research the refractive phenomena, sinking is the opposite of looming, and basically it's the effect and the visual observation of what B-Ball for Life is producing, what I have produced, what others, when they show us a ship cut in half, that's sinking. Okay, so the way that I've processed it, though, is to call it proximate looming, because it's still a refractive phenomenon, but it's been misinterpreted. So both looming and sinking happen beyond the horizon. They happen beyond the horizon. So the question is, well, what's happening in front of the horizon? And is anything going on? No one's talking about that.
Can I give you an example?
Can you?
Yeah.
Yeah, let me
If
finish
you're
my
done.
thought. Let me finish my thought real quick. Okay, so the point is that looming isn't what they think it is, but it's not what they think it is. Sinking, it's an observation, but it's not the phenomenon that they describe. So, in my opinion, those two fields are wide open, and we have an opportunity to stay on the ground or on the water and use a boat. It's gonna be very, very simple. Go ahead.
One example that I've run into on a personal level, and we've all seen it, you just might not have realized it. It's going down the road. Let's say it's a flat road. You'll see that heat miraging right down the road, and they disappear as you get closer, right? Well, pay attention. If the weather's right and everything's right, let's say you're coming up a hill. It could be a slight hill, just any incline.
Right, there's no
Right.
refraction in the background. I'm with you.
Hold on, Brad. The top of the hill is where that mirage thing happens, right? And it looks like the hill I'm gonna go over in about a mile is like lower than it should be. However, there's tall grass on the side, and the tall grass on the side of the road is not miraged. And so I can still see the tall grass, but the road looks like it's about 10 feet lower until I get closer, and then I can see the road again, right? And it goes right up next to the grass. The grass is 3 feet high on the side of the road.
Aaron, what I witnessed is when I got a hump up top with no background, if there was no trees and nothing but sky behind it, I couldn't get no refraction. It was only in the dips in the road that had something behind it. would I get the refraction. So I thought that's
Okay,
where you were
yeah,
going with it. I
yeah.
apologize.
Yeah. I was just going on the other side of it, over a hump that I've seen. You know, where the road seems to disappear, but the road is still there. However, it looks like sky, right?
Did you
You know,
did you send me those photos? Because what you're describing, I think I've looked at, but I've never.
me and you've talked about it before.
Yeah, because I remember looking at some footage. It was like that, where there was the side of the road had tall grass, and
But the road was missing. Yeah,
Right,
the road was
right.
missing.
Yeah.
But the road is still there. Remember? So
Yeah.
the-
Right. Yeah.
Yeah.
Yeah, that would be good to find that footage as just a collaborative.
Listen, that road is absolutely not rising up and covering the light, okay?
So a car that was actually, if I could, you know, just perfect timing, have a car or even a semi going over that hump I'm talking about, where it's miraging, right? It's going to be, the semi trailer is going to be half gone. The road is still there, the semi is still there, but it's going to look, obviously, you know, gone, you know, until I catch up to it. You know, catch up to the road, catch up to the truck, and everything's there. And it does have something to do with curvature, I guess, because there's a hump, but we're just talking about miraging, you know.
Yeah, there was a lot about that discussion with Ruhif regarding light that I wasn't that keen into getting into today, but was just like, what the hell are you talking about? So what I couldn't get through was, and Bob, you tried, was the light. You know,
Yeah,
just
I tried.
very simply, even though perspective is causing the sun to look lower, still has to travel from where it is up wherever it's at through all these supposed density layers of atmosphere, right? Just because it looks like it's down here doesn't mean that it doesn't have to travel through that, right? It doesn't mean it just travels through, you know, this
It doesn't mean
layer.
it's actually at 90 degrees. Like if you can extend that line out as far as you want to infinity, as long as that sun is following the track above the flat Earth, which he gave us the flat Earth. As long as it's on that track, like we would normally, you know, say it is, at least for now, it will never be at 90 degrees or at 0 degrees. It can't be, or no, 90 degrees. 90 degrees. It can't be.
No.
Because it's always above it. So yeah, that's exactly what I tried to. I mean, if you look at the picture, and yes, it is a cartoon.
Yeah.
But I wasn't saying the cartoon proves reality. All I was doing was using a cartoon to provide you with an idea of a concept, and the concept is simply a logic concept. It's not a matter of opinion or interpretation. It's just logic. If your sun is following a track, and the track isn't deviating, then it's not gonna go up or down. It's just going along the track, and it never actually goes down to that degree point. But he wouldn't. Either he can't or won't.
Right. Yeah, and I was getting frustrated with Ruhif, and Ruhif, I do apologize, but I kind of don't apologize because it's like you're playing dumb. It's like, did anybody else get that feeling like he's purposely not dealing with what we're talking about, the concepts that we're trying to
that's why I
discuss?
said. That's why I said he's trying to monopolize nature. So and no matter what we show him, he's gonna have equal and opposite explanation by his own right.
And I think
earlier. What's the
Jimbo
difference?
said it best. Yeah, Jimbo said it best.
I still like him though, man. I still like the guy.
Ruhif was not listening to your presentation at all, Brandon. Jimbo said that.
Oh, as soon as Rumpus jumped on and gave him that excuse, he was like, boom, I'm running with that.
Oh man, he latched onto it like he was starving to death, and and Rumpus had just thrown him some KFC or something.
No shit. That was funny. I'm like,
seriously.
oh, this is over. This is done. He's not going to
That's
pay
kind of what
attention.
conspiracy cats did too, right?
Yep.
He was basically fumbling over himself, and then he just like Rumpus like da 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 da, and he tosses something in there, and conspiracy cats just goes at it like a rabbit animal.
Oh my gosh.
I swear it's like these people are like on the same program or something. I swear it's like they're all like the same club or something. Like, I don't know, they went to NASA together, or they're in the same Masonic lodge. I mean, it feels like you're dealing with that with all of these little
It seems
It's
so.
sort of like in Mission Impossible when they play that tape, but instead of, this tape will self-destruct, when they hear the end of the message, the globe will self-destruct.
Hey, I hope everybody on this panel watches that link that Brandon posted about the Rumpus video. It's you got to be a little bit patient, but it shows his general comprehension on what's going on around him. It's pretty revealing, man. And hopefully, Rumpus, if you're listening, you will watch it, so you'll see what's actually going on around you, and when you're in your own little stupid ass world.
It could have been anybody else besides Ruhif, any baller. And the content that would have been the same on this show tonight, right? Because that's like what Lemon was just saying. It's like they're all in this exact same mindset, or whatever bubble, whatever it is, right? And that's why the Brian has to give shout outs to Rumpus for breaking the ice a little bit and actually, saying, hey, good job on a video or something, right? We have to actually, cheer, stand up and cheer because, one of them broke out of it,
Yeah, it was refreshing to hear somebody, acknowledge what we see in front of our eyes. That nothing pisses me off more than when someone is just flat out denying what they're seeing right in front of their face.
Yeah.
But they probably feel the same way about us sometimes. But I definitely agree. It seems like they're all on the same
Evaporation
page.
brought up a good point though. Well, whenever he was asking him why this guy that you got that picture from, the cameras, why would that guy have not had them level? Like,
hey, who's this,
it's their guy, isn't it?
Who's this? We can't see through a clear atmosphere.
Yeah.
Yeah, exactly, that kind of thing. Yeah, why wouldn't
Can't
they be level?
see. It's clear atmosphere. There's no about.
If they're going to whine about the levelness of the cameras, then it's like, why is your guy going up there and then having these goofy cameras up there and then trying to claim stuff with it? Why isn't your guy keeping the camera level, you loons?
Yeah, I'm gonna have to give that some thought because I don't see how they could angle them and how that would play with having one angled or if they're both angled. I don't. It just doesn't make sense to me to do that. If there should be offset from each other, right? If there's one angled and what non-angled.
You have to go back and listen to what Ruhif said when, because I know you were in the heat of the moment when you're trying to do your presentation, right?
We're off by a
Ruhif
factor
was
of
just
10
like,
to the
I don't know.
120th.
I don't know. I don't know.
That is one with
right?
120
like, why would he do
zeros
like,
after
he,
it.
he could not
This
even
is the largest mismatch between theory and experiment
support
in the history of science.
the footage you were showing of Mr. Sensible's balloon footage, right? He couldn't even support it because he doesn't know, and we're just like, yeah, you don't know.
Shout out Michio Kaku. Thank you very much for the $5. Yeah, so it'll be interesting to see what they come back with on that. But this sun traveling through atmospheric density layers, I think they're completely discounting this, I guess, as Ruhif would call it, the horizontal density layers. When you go from warm to cold, this is a lot more complex than they're giving it credit for.
Yeah, because you got a couple major events up there. Hey, it's hitting. I think it's a focal point because it's slamming into a layer of moisture. Okay, that's why we see it in the clouds. That's why it shines on particular clouds. One thing the high altitude balloon footage does reveal is hot spot. About 1 in every 5 high altitude balloons, you'll see a hot spot on the clouds. They can speak out. They can write off one of them, but not not that many, and it's a regular phenomenon now.
Yeah,
And
and the moon too on the right. There's been balloon shots of the moon with one of those, hot spots on the water, and wow, same thing as the sun.
So common sense. How common sense? How can we see how can they claim a sun is 93 million miles away? Maybe 200 years ago, okay, maybe it was a gas 200 million or 93 million miles away. But now, with everything we see, that's insane, man. It lights up local clouds right in front of it. It doesn't light up everything in its path like it would do if it's the way they describe it. I mean, it's speculating. I know I don't like to make positive, definite claims, but it's fun to speculate, and that's what we said we were going to do, is try and figure out our own model of the sun. It's going to have to involve sun setting somehow. We can only describe how it we don't have to bring this into the debate, but when it's just us talking, I know we all want to figure it out. So we have a couple options. We have it hitting the density layer with the focal point, which would work in the with the experiment, the Eratosthenes experiment. It would have to be some type of polarized light. It would have to be a reflection. It would have to be a focal point or going through a lens. It would have to be one of the three, unless you know something I don't know. But each one of them would explain it. To me, when it's just us and no debate, we pick up where Ranty left off with the working out what the sun's doing. It wouldn't be that hard to make up some math. They come up with some crazy bullshit on what's going on with the sun on the horizon. We can do the same.
Yeah, absolutely. And I wonder if there are some experiments, some easy stuff we can do to try to learn a little bit more about how the sunlight is traveling. And I think Travis hit the nail on the head regarding what's happening in front of us. So some of these observations, like what Rakia posted earlier, where there's no mirror and it's blocking, is there an experiment we can do to try and recreate that? I think
we start off with what we know for certain. And like Travis is saying, he just reworded it, but yeah, we start with what we know for certain and what we see happening. And I want to say one more thing. We know that, okay, so if it's above us, obviously, okay, duh, it's got to be going through. If the Earth is a vast plane, it's got to be refracting through a vertical gradient over distance. And so there, you pick your poison. You have where it's hitting the vapor, the water. It's getting introduced, slammed into water, and it's you have two gradients. You could use either one. The inverted temperature gradient up there, where there's no pressure and no water vapor, or just a big temperature gradient, or just the vast pressure gradient. Take your pick.
Yeah, exactly. So yeah, I'm looking for something practical that we can do, especially this proximate looming. Travis has been messing around with I think it was a Fresnel lens, wasn't it, Travis, in your video a couple days ago?
Yeah.
Is there a way that we can recreate that, something similar to what Pebbles did?
Yeah, I don't know.
With temperature or humidity or reflective surfaces or something, some kind of proof of concept to show that happens. And do we even really know what's happening? Is it the foreground? It appears to me and that the foreground is looming, for a better sense of the word, proximate looming. Or is it really the background that is sinking?
Okay, so I wouldn't say that it's sinking per se. So the problem, if you go to Andrew Thomas Young and read through his descriptions of each of these phenomena, and then look at his diagram that he shows to the margin, he doesn't ever show you a real picture, which just bothers me to all hell. So take looming, right? Looming is the bringing up from behind the horizon into your view something that you couldn't see because the curve was there. Okay, so my question would be, Andrew Thomas Young, show me the before picture. What am I not supposed to see? Take that picture. Click.
That's where you get cartoons. Okay, so they know fuck all
on,
about
Brian.
these long distance atmospheres, bro.
Yeah. So then he just draws a picture. He draws a triangle, and he shows the triangle either smaller, to scale, but drop down or raised up or whatever, right? But what is that triangle in reality? Like, give me is that a tree? Is that a lighthouse? How am I supposed to make sense of this in reality? And then I can show you what I think looming looks like. I can show you what I think sinking looks like. But yeah, so the only thing that I know that Pebbles has demonstrated, but that those things are out there, is that they can recreate inferior mirages. They can do that. Yeah, go
ahead. Sorry.
Yeah, I'll wrap it up. I'm sorry. I don't know that they have reduplicated Fata Morganas or superior mirages or looming, towering, stooping, or sinking. I don't know that those have been reproduced.
I agree. And one thing you can count on, Travis, is that whatever effect they give you is going to be for their model. Okay, I agree that there's might be a couple of them that could work on either, but the effects, watching your videos, going through Andrew Thomas Young shows their all the gaps in their understanding of what's going on out there, man. And I consider you the forefront on putting this shit together, man. So, man, it's we got to talk about this more, man. We do. I'm with you, man.
Well, I agree, and I want more people discussing this because I would say that more hands make the work lighter, right? And the ideas that we can put out there are gonna help us progress. But you're right, Brian. When you look at this stuff and just take a step back, the assumptions that Andrew Thomas Young makes is right there at the beginning. He assumes that the Earth is curved, so that everything that he describes is according to that model. Now, again, what happened tonight when Ruhif asked you, Brandon, he said, "Are you assuming a flat Earth or a globe or whatever?" Now, I would have said it doesn't matter because the phenomenon is the same. So let's just deal with the phenomenon, because that's where I've come in when I started taking my photographs, is that I understood that when a baller sees the limit of the water in the distance, that's always curvature. I mean, if you want to trick somebody in the next couple of days or whatever, just find a picture, any picture of the horizon, and say, what's creating the limit of that water? Use one without a mirage, use one with a mirage. My bet is it doesn't matter what that picture is. If the water ends and doesn't go any farther, they have to say that it's the curvature of the Earth.
Yeah, and if you really think about it, Travis, I mean, they say that the flat Earth concept is archaic. It's old and simple. But if you think about it, the heliocentric model is so much simpler. Just to put a celestial dome above us and map everything out with azimuths, it's going to make for a way easier map. Okay, it's going to make for way easier explaining phenomenon and refraction, all that stuff. The flat Earth model is going to be more complicated. There's no doubt about it. And I think back in the day, it would have just been a lot easier to map it out as with
Maybe if you ignore the reality of angular resolution and just say that it's a hump of Earth curve blocking light reaching your eye, that's going to be very easy, but that doesn't match what we see. Objects reach a vanishing point, and by that extension, visual zones that you're seeing through would reach a vanishing point if they're real objects with length and thickness, just like the penny, the car, or anything else that's vanishing due to angular resolution. That's the most consistent interpretation. So these refraction models are off because they're not including angular resolution. These globe models are off because they're not including angular resolution. We have a serious problem here.
Right. So we need to get a dream team together of investigative collaboration. To each of us has his own strengths to add to this discussion. I mean, somehow we've got to figure this out because it's been, at least for me, 3 years, and no one's stepping up to take this to the next level. We're all still in debate shows.
Well, what would you like to see happen, Travis? Because I know at one time you were talking about we need funding to spend some real time on it, but I don't know how we can go about getting funding. I mean, I'm not saying it's out of the possibility. I just don't know how to do it. Is there?
Well, I mean, if you just think about science done back in the day, right? They were artists and specialists in their field were commissioned. They were paid for their time to produce results. So I can't imagine that there's not some philanthropist out there, right? When I went to college, it was a Bible college. There was a lot of people that donated money for students. And you could go into the student loan area and look through their index box, and a person would say, if a student is from California and his parents are divorced and he lost his dog when he was 10, I'll pay for his tuition, right? Just somebody who wanted to give their money away, and they had just these certain qualifications for it. So I'm saying there's got to be somebody out there that's got money to just burn, right? Tax write-off, whatever. Or there's got to be somebody out there who is in the academic field who knows how to move a grant application along. I mean, I'm lazy, okay? I love getting out and taking pictures. I do not want to research how to find a grant. And actually, you know what I did the other day? I went on and I did it, right? So I typed in how to blah, blah, blah. So I'm scrolling through the first page. I'm like, I have no clue which one to look at. So I click this one. Starts taking me through all of this application process. I got to the end, like 10 minutes later. You're going to have to pay $29 for us to process this. I'm like, fuck you. I don't even know who you are, really. You know what I mean? There's no way I'm giving you money. Like, this is crazy. I am not wasting my time, but I don't know how else to get the money either.
Well, do we know any billionaires who love flat Earth who want to?
Yeah, we know a millionaire in Australia.
I don't know if he's interested.
I know, seriously. Listen, seriously, okay? So 5 of us pay our livelihood for 5 or 6 months, right? Figure that out. I mean, that's nothing. That's chump change, right? We'll rent a house on the in California or in Louisiana. We're going to find one spot. We're going to do all that we need to in that one spot, right? But we've got to have more than one person. We're going to need a boat. We're going to need, so, it can be done. It can be done.
I wonder if there's any of these government grants out there that we can get for like scientific research. I mean, we're paying all our money into taxes anyway. Why not try to get some of it back to go out and do the science we want to try to do? I don't know. I worry about bringing money into it like that. Let's say some billionaire came along and was like, here's some money, do it. Because once you get a taste of that money, then it becomes a job. And people tend to want to perpetuate that funding source and become dependent on it.
Then you're kind of controlled by, you'd have to really trust the people funding you, because you'd have to find somebody honest and true, because 9 out of 10 or 99 out of 100.
You're roboting.
That's
breaking up. Yeah, me and Travis talked about this, I think, a while back. About he had Cleary. Sorry, Brian.
9 out of 10.
Brian,
be people
we can't hear anything you're saying, Brian.
Okay. All right.
Until
so
now.
me and Travis talked about this a while back, right, Travis? Right? You had you were trying to organize a few folks, and and not looking for funding or wanting funding, just saying, hey, would you fund this? And remember, I told you absolutely, but I want, like Brandon was just saying, I want a schedule, I want a plan, who's controlling the money, you know, what, like it's really logistical when you start adding the money, you know, into it, you know. So not saying that folks wouldn't give and not respect the return would be the evidence, but you know, just who's going to control it, right? You know, when money gets involved, it's like things get sketchy. Right?
They do.
You know,
and that's what I worry about, just being co-opted, or you know, having our objectivity, you know, whatever objectivity I have, our own personal, what is the word for it, sovereignty over our minds, bought or co-opted. It could be done. I mean, if someone came along and dumped a bag of money on the porch and said go out and research, that'd be cool. But I you know, I think we can do it without funding. I think we can do it without funding. And what would be in it for the people who were funding it anyway? I guess scientific advancement, but you know.
Well, for a guy like me, let's say, it's because I am not and I will not go out and do it. But Travis can, right? And I trust Travis. I've met Travis, right? I've talked to him now for 3.5 years, where, you know, I trust Travis. But, you know, the whole group that may be created, you know, the idea of, okay, we're going to buy this, buy that, and Aaron, you know, for your funding, you know, we're going to do our best. And I would be like, okay, I trust Travis, but you get more people involved, and then maybe even more funding, and like, well, we need a bigger camera, you know, we need, okay, where would it end, right? If would Travis show me a globe Earth, right? If he went to Pontchartrain and said, I've got the airplane, I've got the boat, I've got all the cameras, and that fucking bridge is curved, bro. Right? You know, would Travis say that? Would he, you know, concede to me? Not that I'm super worried about that, but, you know, when you're in that environment and you're looking for what you want to find, and if you don't find it, would you concede it?
Right.
You know?
That's what I think happened to the old London, you know, group, the London Society. What was it called? When
Royal.
Newton and all those guys were a part of.
The Royal?
Yeah, the Royal Society of London was sponsored by the Queen. So these guys are sitting around, you know, they're all like from well-to-do families, and they're all occultists and interested in this shit. They're like, oh, the fucking Queen wants us to pay us to go out and prove that we live on a giant fucking ball. You know, these guys were religious nuts anyway, so they had all these crazy ideas. Sorry for the terminology, not really religious nuts, but they had some pretty far out there ideas, you know. But I don't know, you go out looking for something, you're going to find it, especially when the next check from the Queen depends on you showing her proof of her ball Earth.
Well, you have to make the test in a way that makes it objective and definitive as much as possible, you know, like shooting a laser or something. Most people, you know, despite all their protestations to the contrary, think that a laser travels straight and true in an EMF wave too. You could build in, you know, controls like that, or, you know, other stuff or whatever.
Yeah, right. Anyway, so we kind of meandered off into a bigger discussion, but I was just trying to think if there's something we can do, you know, right now, some kind of experiment that any of us could do, suggestions. And I did get a suggestion from Gleam in the chat, and I thought it was a pretty good one. It's another fish tank one, to section off the fish tank into 2 sections of different temperature water, like a divider in the middle of the fish tank. And then remove that divider at some point and film what happens and how that impacts the light through there.
Yeah. Yeah, I think that's going to be tricky because that's what I was trying to do that, but not with temperature, and I was using two different lenses, but the lenses would counteract each other. So I had a large 14-inch Fresnel lens that I put up, and I could make my observation magnified or diminished. But then when I put the other lens in front of it, it would flip the image. You know what I mean? So it's not, at least in that scenario, I couldn't combine both of those methods. But a temperature thing, that would be, I don't know, that would be interesting because you're going to affect. Yeah, it's interesting. It's interesting.
Let me ask this. You know, what more could we do? That's Brand. I heard Brandon say that. You guys have already done it. Travis, Ranty, Paul on the plane. You know, just Peter the Great. I mean, just everybody. You guys are out there showing it, and I've missed a fucking million of you, but you know what I mean. You guys have already done it. So what more can you do? I don't know. Right?
Well, I appreciate that. I think there's a long way
needs to be tested. I was going to say, the thing that I said it before, the thing that needs to be tested is the physicality of the Earth, because optics are always going to be open to argument, debate, and oh yeah, but this, and oh, it was refraction. Optical, as I'm not trying to demean it, but it's always going to be an ambiguous argument.
Yeah, and at the same, I agree with you. At the same time, because I'm big on doing a physical test. We've talked about it for a long time. But the one thing with optics is that's how they built the world.
Optics, man.
Trying to figure out how they built it and trying to understand the way we see it. I still think it's important because everything is optic. I was talking with Ranty about this earlier. And he was saying, how would they tell a blind man that the Earth's a sphere? And I was trying to think of different ways, and they come up with some like weight differences at different latitudes and pendulums. He can't see a pendulum. So how would you convince a blind man who never knew what shape the Earth was, that he's living on a sphere?
But how would you convince him that it's a globe either, or flat? You know.
And first, you'd have to establish a very trusting relationship with that person, because everything that their senses were telling them, they wouldn't believe.
Yeah. Okay, great. So that's exactly what I was thinking, Effie. So this was one of my empirical revelations when I first started thinking through this. Everything that we experience on a local level with our bodies, we can sense movement and angle, right? If I lie down on a piece of plywood and you elevate any part of that plywood, my body knows, right? So I know, and if you hang me upside down, I know it. And if I try to stand up at a 90-degree angle, no way I'm going to do it. It doesn't matter how big you make that surface on which I am. So let's just say we can manipulate everything in the world and I'm standing on the top of the world. If you then turn that 90 degrees, I'm going to fall off. Okay? That's the way things work. So Effie is exactly right. The blind guy is going to go, there's no way there's someone upside down because he'll fall off. There's no way that there's someone at a 90-degree angle. That doesn't work.
Yeah, but the wide awake guy with two eyes, two lenses, right? Imagine you take a lens, because we're all focused on these lenses, whether it's cameras or eyes or telescopes or whatever. If you continue that lens, right, you continue the curvature of that lens, it ends up somewhere, right? It ends up in a fucking sphere. Right, if you were to continue that lens, make it bigger and bigger and bigger and bigger all the way around, it would end up in a sphere. And that's exactly what we are up against.
Well, the crux of the argument has kind of, in my mind, been that they took a mathematical aspect of the world, which is visual space, physical space
lens,
looking smaller and smaller as you go out, and these mathematical relationships of how we see and perspective and they made it a physical ball, right? Instead of representing it as a flat plane with these mathematics that were, what's the right word? It's not exponential, but there's another word for it. They made a ball and made the mathematics all, straight sight angles, right? They took the perspective out of it. That's been the crux of the argument. So I do still think that optics is at the heart of this whole misunderstanding or issue, however you want to frame it. But at the same time, a physical experiment would be fantastic.
Well, it truly is optical when you're talking about it ramping up to the level of the eyes, and so a blind person isn't going to be able to appreciate it because they're going to, use sense and touch and, possibly some sound or some other senses to approach it. So you'd have to give them a flat plane to feel versus a globe and ask them, what do you think the Earth is? So the shape, I think it's like a flattish pizza and or, round. They typically walk around with their feet, say it feels pretty flat or round, and say, I guess I would say that it's probably flat.
Yeah, and y'all have seen those eye tricks, right? The eye tricks, whether it's through the shadows or shape or just the way the picture is presented to you, your eye fucks your mind up a little bit, right? Until you know what's happening, then you can see it. You know what I mean? But what was it called? Those brain games, right? They did all that whole series, brain games of optical illusions, And that's exactly what optics can do to us, which we observe every day.
Yeah, speaking of which, Jeremy sent me something really cool earlier, if you can still see my screen. It was some of these optical illusions on 2D paper. I'll just share those with you. Our eyes can definitely be tricked, that's for sure.
Yeah. Look at that.
We have optical illusions. We don't know what's in front of our faces, a few feet in front of us.
Until you go touch something, you can never be sure.
Look at the lights and say, oh, there's nothing of optical illusion in anything up there that we're looking through.
Right. That one's really cool. I mean, that looks like a freaking chain.
That's nuts, man.
I know. I wish I could do that. Those glasses are wild. I mean, there's just some wild optical stuff.
And, we see, through a medium that is fairly faithful, but that can wave, undulate, go crazy due to heat, and sometimes doesn't give a faithful rendition of the object itself. But it does the best it can. It's a medium of air, and sorry to use that keyword of ether as well, that tries to be faithful as much as it can be and participate as little as possible in the interaction, but it still has to bring whatever it is to our eye. So,
I see ether written all over this little optical illusion drawn on paper with pencil. I see ether all over the fucking thing in my optics. Oh yeah,
we have to take into account and how faithful this ether band or whatever.
Hold on, guys.
The eyes. It's all good. I knew it was going to be.
Can they not hear each other?
It is what it is. But this medium will be as faithful as possible with some changes. We just have to deal with it.
I agree with Lemon.
Yeah, I only heard half of it, but anyway.
Hey, Brandon.
Yeah.
Hey.
Oh, hey, Gary.
The
What's
measurements,
up, man?
when you get towards the... Oh, not much. I've been listening. For some reason, I always have a hard time connecting with your show, but I figured it out. I think I got it down now.
Oh, good.
But anyhow, if 90 degrees is straight up and 0 is perpendicular, to the ground, right? You're always going to have the most compression at that point, which I think that's where the measurements are messing up. We're not accounting for that compression. It's like when you look down a hallway, if you're right in the center and it's a square, let's say it's a square hallway, everything's going to move, on the sides are going to move inwards, the top and the bottom are going to move up and down, right? And they're going to go towards the center. But everything gets more compressed as you get to that point. And that, of course, is where your eye level is going to be at the horizon. it doesn't. The horizon never meets your eye level, but it's always right next to it, because in the distance, when you're just looking with your natural eye, that space, let's say you're 20 feet above, you're 20 feet high. That 20 feet at that horizon is nothing, right? It's basically matches the surface almost. You might see a little dot.
Oh yeah,
but
yeah.
I think that's where we're missing the point, and that's where the measurements are messing up.
Well, that's kind of like what I was showing earlier with this, trying to calculate the distance in this footage. As you go closer to this apparent horizon, using their calculations, I mean, the visual space, this little visual space right here is, let's see, let's go with this one. This one right here is like 1,300 kilometers. This one down here between the blue and the yellow lines is only about 150. So it gets compressed to hell. I mean.
Oh yeah, and so and that space, you have the things like the atmosphere, and like your video you showed yesterday. That little atmospheric stuff, combined with the smallness of whatever you're looking at that distance, is going to blur out the bottom, because the bottom is always going to be the closest to the center, which is going to be the most compressed.
Absolutely.
And it's always going to be bottom first. It can't do anything else. It has to be bottom first. And just by the sheer angles and just the inability of your eye to resolve things at a distance because of the narrowness of the angles.
It's the only logical conclusion. That the
It
bottom is going to
happens every
disappear
time.
first.
I mean, this is just how we see.
But you try and tell them that, look, and you try and tell them that, and Ranty shows them a boat with the literal word on the boat compressed, and they still just ignore it like they never even seen it. So it's literally spelled out for them on the side of a fucking boat, compression, and they won't even acknowledge it.
I made a video of Critical Think showing all he did was changed elevation, and it totally compressed the letters at the bottom of the ship into a little small space. And then, of course, he tries to claim refraction did it, or that it's refracting up and somehow it squished it. I don't know. They have to make up all manner of garbage to try to convince us that we're just.
Well, think about it, man. When you zoom in, you
Oh, you're robotic again, Brian.
spread the lights out. If you're looking at
You're robotic, Brian.
Can't hear you, Brian. Can't hear you, man.
Damn. Yeah, here's your channel, Gary. So, is that your last video?
Basically, as God.
Oh,
I don't know. I don't remember what it was called. It's one of them.
How about
it's got critical thinking. It's I can't remember what I titled it.
Man.
Okay.
I don't put a lot of effort into my videos. But even my last video, that's another one. Oh no, that was from John D. And all I did was showed those turbines, and there was a ship that he had in the same video, and there was a red portion at the bottom of the ship, and then the turbines had a yellow portion at the bottom at the base, and you could clearly see him. But then he backed off the zoom in his video, and as he backs off the zoom, it's compressing. The angular size of that yellow at the turbines and the red portion at the bottom of the ship becomes so small, it becomes where you can't resolve it as separate from the water line anymore. And it's like, so that's bottom first right there, and that's just showing it just how it kind of shows how our eyes actually work by using the zoom. But I don't normally like to use the zoom because to me it's like pseudo perspective, but it kind of shows that. And then I had a Blue Marble. He took a screenshot when it was halfway zoomed back, and then he expanded it, or he zoomed back in on the screenshot, and he said, "Oh, look, it's all still there, except for then the colors were all messed up. They were way lighter because, that's another thing we don't account for. Like colors in the distance, they start to fade and melt together. And artists use that concept when they paint and stuff, or when they want something in the faraway distance, they kind of blend the colors a little bit and make them more neutral, and it gives the perception of distance. And so we see that same thing. The farther something gets away, and maybe that's because of the atmosphere, that it starts to fade to colors, and it's all of that is combined. All that is combined into what we're seeing. It's a whole bunch of things, and I think all of us are kind of nailing little aspects of it, and we're putting it all together. And these guys are running scared now. I mean, you hear them. They're giving in inch by inch. Look at Ruhi. Was it yesterday on your show that he was? He kind of gave in on your video, right? The video you played.
Oh yeah, he acknowledged
and
right
how,
away. Yeah.
Yes, and so it's like inch by inch. You know, now you got Blue Marble and you got Bob the Science Guy, basically admitting Coriolis is nothing. You know, it's like you might have. Well, maybe it was you who had a big argument with him.
Rumpus giving
Rumpus.
It was me.
Yes.
And you know what? I've been
Hey, am I
meaning to
coming
put
in any
this
better,
clip
man?
up.
Am I coming in any better now, you guys?
Yeah. You
sound hot.
You
Yeah.
are loud. I'll have to turn you down on this side, but yeah, you sound better. Here, let me get this out, Brian. Then you can go back to what you were saying.
Yep.
I had
All right, I'm next, Aaron.
I had a discussion with Blue Marble. I went over to Jose's. I don't know, it was last week or something, and just calmly talked to him about plane flight and asked him, "Is there any difference? Would a pilot notice any difference? Would you expect the pilot to have to do anything if they were flying over a flat plane as opposed to a spinning globe?" And he essentially said, "No, there is no way. There is nothing that you can do during the flight. Nothing the pilot does. No sensor or instrument that the pilot uses that will tell you that you're on a spinning globe. It's exactly the same as if you were over a stationary Earth. I mean, it just in plain words."
I heard that. I was laughing my head off while I was listening. Would he have said that 6 months ago? No way.
Would he have said that to me? Hell no. But I'm gonna say this. What I was trying to talk about. I'm so glad, Gary. Gary, I'm so glad you came on the show. I was like, I think I put it in the chat a few times on the show. Like, man, come over to Ranty's, man. Very good, man. We need your voice over here, man. You got great ways of voicing what we all see, you know, like Travis, you know. And but anyway, so I want to say. I want to say this, man. I want to make this point real quick, okay? So when they talk about optics and they think that we should be able to infinitely zoom, they're acting like we're literally our eyes are reaching out. When and you got to explain it to them every time you debate that it's just the light. When we zoom in, it's just showing us the light that is already there. We're not seeing like through telescopes. We're not seeing further. Just the light that's naturally there. So light that has reached certain angular cutoffs, you're not going to be able to bring them back. So I think a way to prove this would be like to take a cross, just visualize a cross and put a light at the top and the bottom. So they're spread out a little bit more than the ones right to left. Say like a cross with a light at the end of each point. And you take it off in the distance, okay, and you zoom in, okay. So you're going to hit a spot where, okay, you're obviously going to lose the one from the top that you zoomed in. So that right there, to me, I'm trying to find a good way to put this. That would show you right there that you can't bring back something that has already hit the Rayleigh criterion. In other words, you can't zoom the bottom down if you're zooming the top down. Also, in other words, the bigger angles, the bigger the zoom capability. So the two top and up and down from each other you're gonna lose them first from each other, but you're not gonna be able to bring the one back past. Oh man, I'm having a hard time wording this, but I'll try again later.
Draw a diagram of this, Brian, because it sounds like an interesting experiment.
It's past. Oh, sorry.
Oh, go ahead, Gary.
It's past the limit of the angle. That's why whatever angle you're viewing from is based on your elevation over the surface, and there's a limit for your eyes in that angle, what your eyes can resolve. And then if you have like a P900, it's a whole nother limit. You know, it's still limited by that angle, but it's magnifying what's within that angle. And it's like, so of course, if a ship has passed that point in that angle and it's still further in the distance, it's too small to resolve fully back. But you notice how many times do you zoom in where you can't see something, and as you're zooming in, it's popping up from the center, right, upward. And it's like, I always tell these guys, it's like, wait till they invent a P2000, then you're going to have to change all your arguments again. You're going to have to come up with a new curvature, because that's what we see every time, and it's just like when you zoom out, or when you zoom in on something, everything expands out from the center. And when you back off the zoom, everything contracts and compresses back to the center, which to me just gives the whole thing away too. You know, it's like, it seems so obvious to me. But I know it seems obvious to y'all. I think your group of guys is kicking butt. It's like you guys are finding little things by little things, and these guys are gradually having to admit more and more.
One thing we shouldn't
and that's
do,
why they're
thank
getting
you.
so angry.
Well, thanks, Gary.
Yeah, thank you, Gary, for coming on. One thing we shouldn't do is forget though, like cool things like I think it was John D. France from England. Remember that when Ranty posted all that?
Yeah,
like, through the wind turbines. Yeah, we kind of forget that. We kind of just get excited and move on because that was a point, and we move on. But we can't forget that. Always bring that up, dude. France from fucking England, dude, or it's Manchester, whatever, wherever. I think it was John D.
I think you're right. It was in the same one that Gary was talking about with the wind turbines that are like perfectly sitting on the freaking water.
Exactly.
That was some amazingly clear footage. Yeah, we should look at that again sometime.
Hey, you might need to turn me up now. I got headphones, but did y'all see Gary's little presentation at Jose's where he showed the fact that when the stuff starts fading and barely coming back into view, you start seeing the bottom. Like he threw it right in their face where you could see the colors from the bottom up, literally. I mean, he found a way to demonstrate that. I thought it was awesome.
All it did was
describe that, Gary.
He backed off the zoom, and that's all. He was zoomed in on it, and you could see all this stuff clearly. You could see the yellow portion at the turbine, on the bottom of the turbines, and the red portion at the bottom of the ship. You could see them clearly. But then he backed off the zoom. And as he backed off the zoom, all those things became smaller and smaller, which is what we see, right? If you back off a zoom. And it got to the point where you couldn't resolve that yellow bottom anymore of the turbines or the red bottom of the ship. And they became, because of the Rayleigh criterion and whatever. I think it's Rayleigh criterion, and it's just simple angle. It becomes too narrow. It goes back, when he backs off the zoom, it goes back to what you would naturally see with your eyes. And they all got kind of quiet when they watched it, and then they started making up little excuses, but they didn't really have a good reason, other than Blue Marble. Like I said, he took a screenshot when it was halfway zoomed back, and then he zoomed in on that image of the screenshot and said, "Oh no, it's all still there, except for then the colors were all faded." They were, so he still didn't prove his point. It's like the colors faded. It's as the angle goes back to what your natural eye sees.
Gary, have you talked to FE Data? Have you talked to FE Data yet?
No, I never have. No, I know who you're talking about though.
Yeah, well, we need to get him back. I mean, he's a little polarizing, but he's smart, man. I like him just for his information and his knowledge. And we need to keep Gary, and we need to get FE Data and keep who we got. Nothing against Right the Hand, but man, we could put him up against anybody, but man, I mean, I love him. I don't want to sound like a dick, but as far as exploring possibilities and stuff, I don't think he's this little side team that we're talking about putting together, man. I think FE Data, Gary, Travis, me, everybody on the panel today, man, and I'd say I don't know. I'm willing to take anybody, but man, we're the ones doing all the footwork. Let's face it. We're the ones doing whatever experiments are getting done lately. With a few exceptions.
Yeah, so let's start out with what could we do as a group, going back to that discussion. What could we do as a group for 2 weeks, for a month, maybe? Where
I got an idea.
I'm just saying.
I got an idea.
Okay,
I'm
so
sorry.
That's okay. So let's say, and I'm gonna echo what Brian said, Gary. I appreciate, because like you geek out on what you just described, the way that I like to think that I geek out on photography. But what you do isn't my strength, right? What Flat Earth Data does isn't my strength. But all of us together in the same location, looking at the same stuff for 12 hours a day, talking about this stuff and talking, could we in 6 months take 2 weeks off and meet someplace and devote that time, and then maybe take that body of work together to then appeal to either support to do it again for another or whatever. But we've got to take another step.
I feel like sending
I
a.
call Jimbo as the coach.
I feel like
Good,
sending a.
Jeremy's here too. Good.
Well, Leaky's down to do whatever. I'll have him doing a fucking experiment and after show, but I feel like sending up a high altitude balloon would be a good move for us. There's a couple things we could do right now, just off of like quick brainstorming.
Yeah, that'd be a good
with
one.
the solar filter.
I got one right now with a high altitude balloon. Okay, look, if my theory is right and the sun is the focal point, at first I bought the idea that the sun was washing out the light until I seen the moon, the clouds behind the moon, through a good filter. Okay, and that son of a bitch was not being washed out through no hydrogen alpha filter. There's no possible way. And so if my theory is right and the sun is the focal point, all we got to do, I need to get one more weather balloon and hang some light, fluffy, big shit on it, and we need to just catch the angle right of the sun and put one of the balloons up and tether it to the ground and wait till the angle is about, just send it about 30 miles away, and then get a local balloon and split the sun and and get some real good filters. We need to invest the best hydrogen alpha filters they got, but so we could rule that out or prove it right away, because if the sun's washing out one balloon, it'll wash them both out.
Yeah, my idea was to get a camera send a solar filter up, a camera with a solar filter on it, let it get the sun when it's high up above all the atmosphere, and then when the balloon lands or before it takes off, you take a picture with the same camera, same settings, and then we can compare what the sun looks like, in both of them. Also,
I feel like a dick though, man. Because sorry, man. Go ahead.
Also, I was gonna say get a gyroscope on one so that we could tell when the camera's level, so Brandon can learn more triangles.
I'm not sure if a balloon really.
Yeah, right.
Hello?
Hey, but I must say I feel like an ass because I haven't even done the preliminary fishing line test of just 1 mile. I haven't even done that yet, and I found the line, and I'm like, God, it's like light. But I will get my opportunity, and we just got to keep talking about these things because that's what lights a fire under my ass anyway.
I actually had something to add to your fishing line thing. Your first idea was to tie it off and then just go out with your boat and see if the line sinks, buoyant line. Was that your first idea?
I don't have a boat no more, dude. I don't have a boat no more. That's my main problem.
You can still do it. You can still do this over 2 land points with water in between, and if the line floats, you just have a winch, tie it off on one side. You have a winch on the other side, and you just pull it tight, and then if it's curving, the line should sink.
Like when they told me with their math, I'm not going to go, yeah, exactly. I'm not going to go on and on about this test, but when they told me, when George told me the math and that one pro fisherman, when they told me that that mathematically, the line that I had at 60 yards would sag off the ground if it was 1 foot above the ground. So I stretched the son of a bitch 600 yards, and and I had to put my instrument on it to even detect any fall at all. I had to get my auto level.
I do think
not even a drip of fall.
I think they're bugging with this.
So that showed me their math was bullshit. So I know what's going to happen in the water, but it can't be that expensive bullshit line. It's got to be this cheap ass buoyant line. So
Speaking of high altitude balloons, right? I've watched all of Dwayne Killam's. I've watched every high altitude balloon that I could, even Mr. Sensible's MAGA and all this shit, right? And I always see the sun off in the distance, right? Off in the horizon. Yeah. So I want to know what time he launched his balloon, because if it was, if he's at 20,000 feet and it's 11 a.m., well, the sun should be overhead, right? It should be on top of the balloon. But I never, ever see on every single balloon footage I've watched of Dwayne Killam, who's done the most, right? You always see the sun in the distance when he gets to altitude, right? Always. Yeah.
I've been meaning to analyze that.
I think the one he had, the sun overhead's gone. The sun, the one that was overhead, dude. The sun don't even look like the sun, dude. It's elongated. Right. It's washed out. It's strange looking.
That's why I'd love to have it. That's why I'd love to take one get up there with a solar filter and take a picture of it, and then take a picture of it on the ground so we can compare the two. Also, Brandon had a good idea of measuring the angles of the sun. What is it you were talking about, Brandon? You wanted to do?
Yeah, I wanted to send up a couple, at least 2 balloons at the same time, and measure the angle to the sun from 2 positions. Say, let's say when it's noon in, say, Nebraska, right? Send one up on the west coast, send one up on the east coast, and measure the angles when they both get up high to where we see the sun in the footage. Because I think the sun, it looks to me like the angles aren't right. Like it's too close and it's too low in all the footage. That's what it looks like to me.
Exactly. Did you give him ramen?
Well, even with 2
Oh, yeah, actually,
balloons,
I
what would it prove? The
Ryan didn't need anything.
The sun's position is truly relative to the observer and nothing more.
Well, it might prove that, Jimbo. It'd be interesting to see what those angles came out to.
Yeah. It would, but get the 2 balloons at the same altitude at the same time with the spinning, turning, wobbling.
Yeah.
You know, it's
Hold
kind
on,
of like hit and miss.
They've already got about 18% of the, if you take the 180 degrees of the sun and you take 15 degrees on each horizon, they've already got 30 degrees. That's like almost 20% of what the sun does that they have a bullshit explanation for. So yeah, if we set them balloons up, then we could pretty much make it 100% they can't explain. I'm with you on that.
Isn't it interesting that it's the 15 degrees closest to the horizon where it fails they blame it on the atmosphere, but that's where I would expect it to deviate on a flat plane with a local sun due to perspective. That's where the exactly where the deviations would be.
And that's why when they have the EQ mount, it doesn't track correctly.
Exactly.
Dwayne Kellum launches his balloons, right, at about in daylight. Right? You can watch him when he launches them, right? And, okay, it's daylight. It's morning time wherever he's in California, actually, right? And
he
it
launches
takes about
them right near me.
3 hours. Yeah, it takes about 3 hours for the balloon to get up to 120,000 feet, 6 miles, whatever it is, right? Okay, now that's 3 hours. So now it's 10 o'clock. Now it's 10 o'clock.
Local.
But in all his footage, when the camera's spinning around, like Brian says, it's pretty turbulent up there. The camera's spinning around, the balloon's spinning around. You see the sun like at a 90, like in the camera view, when it should be, pointed up at 10:30, 11 o'clock, right, above overhead the sun. But you don't see that,
I think I know why. It's because the 180 degree view from 120,000 feet or whatever he goes up to is going to be a completely different than our 180 degree view here on the ground, right? It's going to cover a whole lot more distance. So it should, I would think, I haven't thought it through. I'm just thinking it would look like a different angle compared to if you were on the ground.
That's what I'm thinking. That's why I want to do the angle measurements from 2 different positions at the same time. And Jimbo has a good criticism that it's going to be difficult. It's going to be hit or miss. Maybe there's a way to design it to where you can get a steady shot, with multiple cameras or something. But in some gyroscopes, so when it's frickin' horizontal. I think what we're seeing is just the edges of they've mapped our world onto a globe, and it's not a globe. But the mathematics is pretty close, and it doesn't deviate that much. And we're seeing these edge cases. We're seeing the symptoms and the signs of reality in some of these cases, where their mapping doesn't match. But we need hard evidence. So, good.
Hey, in Kellum's video with the stars. I'm sorry, I interrupted you.
Go ahead.
Oh, it's the one where you can see the stars in his video. But I swear it looks like the Southern Cross whenever the camera swings to the south, because you'll see the Big Dipper as it's passing by the Big Dipper, and then you'll see it swinging to the right, and you'll see where the sun is going to come up. Eventually, you can't see the sun yet, and then it swings a little bit more, and it would be pointing more southward. And it looks just like the Southern Cross, except for maybe from a different angle, right?
Yeah.
Maybe they see it south of them. I don't know, but it looks just like the Southern Cross. So maybe you guys can look at it one of these days and see if it is.
Yeah, I've been
'Cause we
meaning
can
to
see it from
analyze all
Florida,
that
right?
balloon footage, but I just haven't got around to actually spending some time on it. I was looking through some of them yesterday, and they're every single one, like Aaron said, you can see the frickin' sun. And it's 93 million miles away, so that angle should be steeper. Like even Mr. Sensible's balloon footage, I looked into it and it was like, yeah, maybe it's about right. It was plausible, but it even seems low on the horizon in his because it's so far away, and it just happens
you
to
were on the
match
ground-
what we would expect to see on a flat Earth.
But if you were on the ground, it would look higher, wouldn't it?
See, that's what we don't
It
know,
would-
and that's what
It'd
the
be
idea is.
overhead, wouldn't it? Like the sun at noon would be over your head. But when they launch a balloon, or Dwayne Kellum and others have launched balloons, and they go up there, right? And I'm not sure. I don't audit Dwayne Kellum, so I never looked if he has a time. He's got all the other data, right, on all this balloon footage. But I never looked if he had a time, because time would be a great thing to know. So if it was noon and his camera's balloons swinging around pretty much horizontal, but kind of up and down, swinging around. And if you saw the sun, but it was noon, got to be a problem.
Yeah,
right?
exactly. We'd have to look for something like that, not an edge case like this. See, the problem with his footage when I looked at it was the sun is supposedly, much further south, so it doesn't rise very high on the horizon at all. It's like 20 degrees, 15, 20 degrees, something like that.
Yeah.
Above the horizon during
Always.
during the winter months. No, I mean that's all it stays. That's as high as it gets when you look south. It's 15, 20. So it's got to be like you'd have to do it when the sun's directly over you for your location, I think. That might
be
you have to think
nice,
about what
yeah,
time of year to do it too.
It'd be an interesting observation to see if you can get the light to shine on top of the balloon instead of catching the sun off in the distance when you're at 10 a.m., at 120,000 feet, 10 a.m., and it's still like way over in the distance, right?
Right.
Like,
All right, let me read some super chats, then we'll go into final thoughts. We can answer any questions that are in these. B-Ball for life, $5. Yeah, you guys still haven't figured out the celestial south pole or the southern celestial pole on your flat Earth. Any responses to B-Ball on that?
There is no South Pole.
There we go.
Nothing to figure out. We don't need to figure out pretend things.
he said celestial South Pole, so he's talking about the sky,
Right.
Right, but that would be a celestial thing that lines up with the South Pole, right?
Why are you talking for B-Ball?
Huh?
Bob, why are you talking for B-Ball?
I'm not talking for B-Ball. B-Ball's talking for B-Ball.
Let's just leave it at that. Right? I don't care what B-Ball thinks about whether it's globe or sphere. Right? He said celestial South Pole. You guys haven't figured it out, right?
I can see how looking at the stars in the south and what we're told about them, you could get the impression that we're on a globe. I can't,
All right, so look.
Go ahead,
Okay.
Travis.
If we just start at ground zero, and let's say it's a couple hundred years ago, and we start investigating geography, topography, and everything, right? We're not going to know about the celestial South Pole. Okay? So all we're going to know is what's in our proximity. We're going to see the sky above us. We're going to see the sun. We're going to see the moon. We're going to see the zodiac. And we're going to see lakes. Right? So my base assumption, and it's very difficult to get back to zero. I can't do it. No one can. But I'm going to tell you, the normal person is not going to come to the conclusion at watching the sky that he lives on a ball. Okay? So it doesn't matter that, if we drew up scientific discovery and then all of a sudden B-Ball comes in from the South Celestial Pole and goes, hey, what about this, guys? But like, What about it? You know, it's the same phenomenon. It's just in a different location. Okay, so here's my suggestion, B-Ball. If the sky does demonstrate that there are two axes of rotation in the sky, is it possible that those are at two different elevations, both spinning?
Good question.
Is it possible? But guess what? We can't get there, so all we can do is just think. But I'm going to tell you what, it's never going to get me to the place to where I think that there is a group of people at 90 degrees for me or even 180, because we cannot exist on those angles.
And I'm willing to put $500 that B-Ball has never observed either.
Maybe B-Ball wants to take you up on that. Okay, thanks. Good answer, Travis. Good response, man. B-Ball for life. Dwayne's video also shows curvature. Are you going to deny that as well? Holy shit. Come on, man. All right. Let me see if there was anything else. I know that there was something else I'm forgetting. Oh, B-Ball for life in Streamlabs donated $1. NM, I get it. Earth is flat. Call me Flat Earth for life. Well, welcome to the club, B-Ball. Appreciate that. And Jose JG donated $1. Sorry, guys. I get it now. Earth is flat. Boom. Wow. I don't know what we did tonight, but that's awesome. Welcome to the club, Jose JG. And the Rumpus also for $1. I get it now. Thank you for helping me see the truth. Earth is not a globe. 3 big wins for us tonight, gentlemen. In addition to Michio Kaku, who said, in cosmology, we're off by a factor of 10 to the 120th. That is one with 120 zeros after it. This is the largest mismatch between theory and experiment in the history of science. Interesting quote that. And thank you again to Nancy Pelosi, Justin Trudeau, and Donald Trump, and Bill Gates for their donations tonight. Thank you, gentlemen. Okay. Let's do final thoughts. Gary, yeah, I'm glad you stopped in. You got to stop in sometime and we can talk about perspective and all that stuff in detail.
Yeah, I'd like to.
Yeah, that'd be great, man. But go ahead. Do you have any final thoughts?
Yeah, whenever you talk about, if you ever get on the subject of clouds lit from the bottom, I know exactly what's going on. I figured it out, I believe, but I won't say it right now. And horizons are simply where the angle over the surface is too narrow to differentiate waves in the background from the foreground. And at the distance to the horizon, they're also very small in angular size, and the spaces between waves are small in angular size, so it appears as a line across our field of simple.
Oh yeah, thanks, Gary.
That's it.
Travis.
I would just add on to Gary's comment, and maybe Gary, you and I could hang out and go up, but I think that it's a little complicated in that, because the medium through which we are looking also plays a part in presenting to us that particular angle when it either raises up the ground or drops the entire view into the background. Much going on.
I agree with you.
Yeah,
and I'll give you the reason for that if we ever talk again.
Sure. Okay. All right. There you go. Thanks.
Or my thought on it.
Yeah, you guys can stick around on the after show. I'll keep the recording going. But anyway, Jeremy. Okay, Jimbo.
Well, I like keeping things practical, and I hate to say it, a bit cheap. You know, when they say things should be repeatable, if you have to have fundraisers and get all this kind of fancy stuff to do anything, it's not practical on the large scale, you know, for a lot of people to, you know, have accessibility and ease of, you know, validating whatever's going on for themselves. So it's not really a good way to go. You know, it has to be more, you know, practical and people-friendly type of stuff and observations, etc. Tools, you know, cameras, locations. It shouldn't cost a lot. It shouldn't take fucking sophisticated fundraisers and, you know, a couple of balloons at once. If it's windy at one place and not at the other and you can't launch that day, you know, you've only got so much budget to hang around in your locations to launch. It's just all, you know, up in the air stuff. For it to work, it's got to be stuff that pretty well anyone anywhere can go out, check out, and at a minimum, of course, cost or whatever, just realize, you know, because the observations and places are all around. You know, like when Sharon and Melissa were doing their mirror and lights on the beach and we're seeing it, I guess, 10 miles away and stuff. It was over then. We're still like, you know, I swear to God, chickens with their heads cut off, trying to prove something to these stupid trolls. And keep going. There's got to be a better way. Good show, though. Enjoyed it. Many more to come.
Yep. Thanks, Jimbo. Aaron.
Shout out to the panel. Thanks, Brandon. Great show. Awesome.
Thanks, man. Bob.
I don't really have much to say, but I'll just reiterate that you got that sun following the track. It's very obvious. It's never going to reach the point that he was saying. It looks like it reaches. It doesn't get there. It can't get there. That's kind of, yeah. Anyway, not much else to say other than that.
Cool, man. Thanks, Bob. Thanks to all the panelists. I really appreciate you joining the show. Thanks to Ruhif earlier for joining and Rumpus for his brief stop on the show. And we'll be back tomorrow, 5:05 Eastern Standard Time, 10:05 GMT. And who knows what'll happen. I'll try to get another debate set up for sometime this week or next week. If anybody has somebody that they would like to debate or a debate that they would like to suggest, let me know and I'll see if I can set it up. Other than that, I'll be back. I'll record the after show in case anybody wants to stick around. And thanks again, guys. Okay. Good show. Good first half. A little less exciting than yesterday, but still pretty good. Will be interesting to see what kind of fallout there is over the triangle presentation, and find out if that camera was horizontal or not. I'm sure I will hear about it very quickly. And thanks to everybody for watching the show. Thanks to those who supported it. Thanks to the channel members. You guys have a good night, and we will talk to you tomorrow. Bye.